Did you already start it?
I did. I just started it. Hey, everyone. Zachary Fruling here, Cozy Azeroth. Said I'm going to mute 1 second because Susan has something to tell me. So hold on 1 second. Okay, I'm back. And actually, I realize I need to change the category of the stream to software and game development. So I'm going to do that. There we go. Set it to the right category here. Update. There we go. All right, now I'm here. We're going to work on our Socrates game. I'm waiting on Dylan. I got to get in Discord here, so give me a second. Let's see if he has any problems logging in. He was having some login issue problems.
Hello.
Hey, there you are. Perfect. Perfect. Alrighty. Well, I was just saying to our audience, since we're streaming already, that we're going to work on our Socrates game. You can see, oh, let me share my screen. I didn't share my screen yet in Discord, so you can see what I'm doing. Oh, you can't hear me? I hear you. I'm going to share my screen real quick while you're doing that. Let's see. So, which screen? This one. Can you hear me? Yep, I hear you.
Sorry, I feel like you can probably hear me. I can't hear you.
I hear you, yes.
Picking up my settings.
That's right, there's no real rush. No one's tuning in yet. Actually, one person might be tuning in, but everyone can wait a minute while you get set up.
Turned on, but as soon as it turned on, it froze. So it's just like frozen right now. I'm waiting for it to unfreeze.
You can't hear me, right?
Log in on my computer. I can't hear anything. I don't know why. My volume's all the way up. There's nothing set turned off, volume-wise. I have absolutely no idea why I can hear you when I don't see any notification or like a setting. Besides this lobby stuff, but everything's turned on. So. I think this was my issue last time on my phone too. It was like I couldn't hear you for some reason.
Maybe I just put it in the chat, but maybe check the audio output settings in your Discord settings.
Absolutely no sound.
I'll text you at the same time. Sorry for everyone tuning in with technical difficulties.
Oh yes. Come on, computer. Get it together. I'm gonna get off on my phone. Just keep going. I'm gonna try it on my computer.
That's okay. I'll wait for you. Got more time than money, as they say. In the meantime, for people who are tuning in, we're working on our Socrates game, We've only just started. We've done 2 sessions. This is our 3rd. We have a basic map system implemented. We are able to move around the map. It's keeping track of which screen of the map we're on. We have borders with doors we can turn on or off, but right now they don't do anything. We need to make it so we can't run through the walls. I think that's our big project for this time.
I can hear you now.
Hey, there we go. Good. Can you see? And you can see my screen?
I sure can.
Woohoo! We're in business. All right. You have an incredible amount of technical difficulties for someone who does technical things.
I really don't like technical stuff. I could really use a tech manager.
Yeah.
The reason I'm not public is because I'm really not good at the tech side of things. I struggle.
That's interesting. Yeah, I mean, it's you don't seem to enjoy it. What's funny is you like video games, which is techy, you know.
Video games. Well, when I was a kid, I was allowed to play video games, but I wasn't like allowed on computers.
Gotcha.
Or social media.
And I always had I had a computer from the time I was 3 years old, so.
Yeah, I wasn't allowed to use a computer.
That's interesting.
Until I was in high school. And by then, it was only for school stuff. I didn't really know anything else to use a computer for.
Mm-hmm.
I wasn't on social media, besides Facebook, which I didn't really like.
Yeah, no, I don't know why anyone's still on Facebook. I still am too, but it's just a good way to keep in touch with stuff, and I don't really care for it.
Same, yeah, I haven't been on in a long time. So I'm just very tech savvy, unfortunately.
That's okay. In the meantime, if you see my screen, I've got all of our code from last time plugged into a real code editor now, so we can work on a real code editor. I have taken a couple of liberties to condense things. I was doing a little bit of mental math and thinking about all the things we want to do and how much memory is realistically inside TI Extended Basic, and I'm starting to panic already. But from what everyone, I so much so that I even put a couple messages on message boards for people that are interested in TI and TI programming. And some nice person even did some experimenting, trying different ways of implementing branching dialogue and whatnot. And the basic gist of it seems to be you need to condense as many lines as possible onto single lines, which is possible in Extended Basic. And also we probably need to use way shorter variable names.
Okay.
But
yeah, I was wondering.
I think for now, I'm not going to worry about it because it's going to be easier to keep things going as we've done them. And then I think what we can do systematically, if we find we start running out of memory, we can do a pass and start condensing these variable names. But for some of these things, like these little lines here, call screen 15, call color, these can obviously be combined. You know, some of this stuff is just obvious candidates for things to be combined. So even things like here, getting the joystick value and then checking the position of the sprite, those things can be combined. So I want to start combining things that make sense to combine from the beginning. But I think the big thing I would like to accomplish today is to make it so we can't walk through the walls.
Yes. That would be awesome.
It would be awesome, because then we'd have a fully fledged world that you can meander around and in a way that makes sense. I think what I might try to do right now, the sprite is being assigned to position 100, 100 right here. I think I want to set it so it aligns with one of the grid values, because the sprites can go pixel by pixel, but the characters that we put on the screen, like these call HCHAR and call VCHAR commands, those plug you into one of the 32 by 24 grid positions on the screen. So what I want to do, I think, is adjust this initial sprite value so that it aligns exactly with one of the grid positions. And that way, I think it'll just be easier to check to see if an adjacent grid position has a wall there. We could do it either way. I would just have to do more math. And I think if I just adjust the starting position and then make sure that when it pops to the other side of the room, that it pops up in a grid position. If I do that, I think it'll be very easy to check to see if the adjacent character is a wall or not. And if we do that, then we can come down here into the player movement subroutine, and we can say, before we do the movement right here, we might be able to just add an extra condition right here. if all of this is true and the adjacent position is not a wall character, then go ahead and do the movement.
Perfect.
I think it'll be that simple. I think.
Go for it.
So I think to start, let's do some of the easy things first. We know, if we know we're going to combine some lines, let's just start doing that.
Yeah, that's a good idea.
Yeah.
Also small. So this one, you don't have to go line by line. Or, yeah. Okay. Yeah, I see. Click around like we did in Pico 8.
Oh yeah.
This is the line numbers like we did before.
Well, we need the line numbers because we're going to copy all of this, including the line numbers, into Classic 99. So we're going to have to keep adding line numbers.
We still need them, but they're not like necessarily as important within this program. Like,
well, this is just a code editor, so this doesn't do anything. All we're doing is writing the code, which we're then going to paste over here into Classic 99.
Oh, I see.
Yeah, we're
not like a simulator in it.
No. This is no game system. This is just a code editor. It's all it is, like a text editor for writing code.
That's pretty cool.
Yeah, it's called Sublime Text, and there's a lot of it can be language specific, so you can say I'm using this language, and it'll highlight certain things, variable names or if then statements, to kind of like Pico 8 did, so you can see what's what, and it'll do automatically format for different languages as well. None of which is useful for doing basic, but it's just a general free code editor, probably the most popular free code editor out there.
That's so cool.
And so at every turn, I just want to keep this organized. So I know this is going to be real tedious, but at every turn, every time we make a change, we need to be making sure that we implement any line number changes, and then any corresponding changes we make, we need to check to make sure that there aren't any ripple effects when changing the line numbers. So I think it'll be fine. Okay, that was an obvious change to make. I think this is an obvious change to make right here. I don't really like multiple commands per line, frankly, but it's going to be essential. There's no way we're going to fit this game into the available memory, even with the 32K memory expansion on the system, unless we do this from the beginning.
Cool.
I did already make a couple little changes from last time.
Yeah, some stuff does feel different.
What's that, sorry?
Oh, I just said some stuff does feel different.
What?
Yeah, that has a whole different look here.
Oh yeah, I mean, this is not the same program at all. This is the environment that we're really working in. This is just a code editor.
Yeah.
Okay. Well, let me kind of do the math here. So we need to make sure, we need to spawn the sprite at, I believe, so at the top left of the screen, the character grid. In fact, let me pull up the, give me 1 second here, everyone. I'm going to hit the BRAC back button. I need to pull up the manual. So let's see here. Let's go to Extended Basic, or TI Extended Basic. I'll show you what I'm trying to accomplish here. So I know I'm familiar with this system and you're not. So, and it doesn't really matter so much, but I think the more you get the gestalt of this old system, the easier it will be to understand what you need to do from a graphics standpoint too. So I want to take every opportunity to explain why I'm making the choices I'm making from the very beginning here. Got to find the right section here. Okay, yeah. Let me zoom in a little bit here. Go to that. Okay, you see this grid on the left side of my screen there?
Yep.
That is our screen that we have to work with in TI Extended Basic. You've got 32 characters across by 24 characters below. And so these commands here that are drawing characters to the screen with call VCHAR and call HCHAR, these draw a horizontal row of characters, HCHAR, and VCHAR draws a vertical column of characters. Those all snap into the grids that you're seeing here. Row 1, column 1, so on and so forth. Now, each of these characters is an 8 by 8 character. What we were calling a sprite in Pico 8, but sprites have a different meaning in TI Extended Basic. Sprites are these things that kind of they can have motion that kind of runs autonomously, so they can just glide across the screen, and they function autonomously while the computer is doing other stuff. So not every character that ends up on the screen is a sprite in TI Basic. The ones that we're drawing for the borders and whatnot are not sprites; they are just characters. So there's a distinction between characters and sprites in TI Basic, if that makes sense. Now, so this grid is for characters. Sprites can occur anywhere along this grid of not just characters, but each of these is an 8 by 8 row and column. So we have 32 times 8 in terms of number of positions across the screen, and 24 times 8 in terms of number of positions down the screen where the sprite can occur, which means that we're dealing with multiples of 8. So if we're at position 1, 1 here in the character, so if we say, give me a sprite at position 1, 1, and give me a character at position 1, 1, both of those are going to align nicely. But if I say, give me a character at position row 1, column 2, that's not going to be the same thing as the sprite position row 1, column 2, because the sprites are dealing in terms of pixels and the columns are dealing in terms of these characters. So we're dealing in terms of multiples of 8. If that makes sense.
Okay.
So what I need to do, I need to make sure that wherever our sprite spawns, it needs to be a multiple of 8, I believe. So when you do the math and divide it by 8, it ends up neatly aligned with one of these rows and columns.
Okay.
So right now we have the sprite spawning at position 100, comma 100. Neither of those is divisible by 8. So what's the nearest thing nearest to 100 that's divisible by 8? I don't know off the top of my head. Let's see here.
80, 88,
96, 104.
96 or 104. Yeah, up or down.
Yeah, let's do 104. And I think as long as we ensure that every movement we make ends up with, and the only concern here I think is we're modifying the position of the sprite based on multiples of 4, I think, because when the joystick moves, that gives you a value of 4, -4, or 0. So we might need to take this value right here. Where are we making the changes here? Let me see. Got to remember what I did here. Oh, right here. We might need to multiply this by 2. That way, rather than moving it by a factor of 4, we move it by a factor of 8 pixels at a time. Right now it's moving by 4 pixels at a time. I want it to move by 8 pixels at a time, I think.
Ooh, yeah.
Yeah, so just it's funny how much, it's similar to Pico 8, but it's a very different, it just works differently than Pico 8, so by a lot.
Universe.
Yeah, and I think that's what I've discovered about, other than the things that we found were very hard when we started making a 3D game, which is why we're doing this instead. I think I found that the vast majority of programming languages, they're more similar than different, but each system is quirky in its own way. And you just have to code around the quirkiness, and that's most of the battle. The logic here is actually really simple. Coding around the quirkiness of the system is not so simple.
Yes.
So at every turn, what I think I want to do, I'm going to copy this, and I want to get into Extended Basic now, which I think I loaded Extended Basic. Let me just double check here. There's 2 for Extended Basic, and I got to remember how to paste in here now. It's not just Control V. There's a paste. Here we go. Paste Extended Basic. Oh, nope, that's not what I wanted. Maybe. Oh, there it goes. It didn't give me the spaces after the line numbers, but it might just automatically generate them, which it did, so that's perfect. So let's make sure we can still run the program. We haven't introduced any errors right off the bat.
Yay!
Looking good. And now, are we neatly aligned? Oh, these characters are not aligned. Are we neatly aligned with these characters? We are. Oh no, we're not. Look. What happened there? We're off by 1.
Can you go into the corner?
Ooh.
Whoa, what the heck?
I don't know. We didn't have that issue before, so. Weird. Why is it throwing an error?
Touching the wall is throwing an error? That's right.
What did I do right off the bat? What happened? I don't know what I did. I changed a couple things here, but
can you load the version before this?
I can, yeah, definitely, because I haven't saved any of this. So let's see, new.
You can make that happen before we did our changes today.
Yep. I'll do a little comparison. Absolutely. So this is the old version that we had last time. Yeah. So clearly I messed something up.
Can you go to the left? Yeah.
Oh yeah. I can. I didn't make any changes at all to this version. This is the version we had last time. So. Yeah, no problem.
Yeah, that was exactly what it, okay, yeah.
So let's list out each of these sections of code and see what I fucked up here. So let's list 10 through 60. Oops. Finicky. There we go.
Let's go. What's wrong with that?
Oops. Okay. Map 0, map X0, map Y0. The doors, those shouldn't be a problem. Go sub 11,000. That shouldn't be a problem. Call sprite. Okay, that's working fine because we're getting a character on the screen. So I suspect my problem I introduced is here somewhere.
Yeah.
So let's list 10,000 to 1080 or 10,000 to 11,000. Okay, what did I do to this? Oh, actually it's too many lines. List 10,000 to 10,050. Okay, player movement. I didn't make too many changes here, so I'm confused with what I did. Okay, called joist 1, joist X, joist Y. That looks good. Fine. Call position. Number 1, sock row and sock column. That looks okay. If sock row minus joist Y is less than 1, then sock row equals 184. I didn't make any changes here. I just literally copied it and then tweaked a couple things. But I messed something up, obviously. Let's change this back to 100. I don't know why that would make a difference based on what I programmed, but let's.
Yeah, maybe it's hitting the edge of the wall wrong.
Yeah, maybe it could have to do with this little bit of math right here. Might be messing it up in some way. It could just be that the value I chose here just happily coincides with the, maybe it only works in a very specific case and this value works okay, but if you deviate from that a little bit. Could be we're getting a negative number somewhere.
Yeah, maybe instead of 104.
But we're covering for that. If it's less than 1, then we bump it back to 184. So why?
Yeah.
But let's do this.
Yeah.
And then let's paste this in now and see if it's working fine before we make that change. Oop, it helps if I paste it in. Remember how slow going it was when we first started on Frieza's Fury? That's what it feels like. It's like it's slow going.
It's very cool though. I mean, we have that. Look at that.
Okay, so that's working now. Okay, so I screwed something up.
There's something with that thing.
Why on earth would it care what the initial starting position is?
Yeah, because that was literally the only thing you changed, but then it messes up whenever we get to the edge of the map.
Mm-hmm.
There's something about maybe where it's like got to redraw us. Because it was that 1060 or 10,060 is what we're calling. What does 10,060 do? That call sprite.
This so basically, so we so the sprite is drawn at position 100, 100 in terms of pixels, not characters. Then line 10,010. This grabs the joystick, the most recent joystick value, which is either 4, -4, or 0 for the X and the Y. Then we're grabbing the current position of, this is giving you the current position of the sprite, or character sprite. And then we go into some logic. If the, let's see, if the row, and it's weird because the row and the joystick value are one is opposite in terms of which sign it has and which direction that means. It's kind of weird. So we take the row and then we subtract the joystick value from that. And I love you. Then if we check to see, okay, so if that's less than 1, so if the row is less than 1, so this is at controlling the top of the screen. If the row gets less than 1, then we immediately set the row down to be 184 in terms of pixels. Then we change the map value, the Y map value. We add 1 to it because we're going north.
Yeah.
And then we go to the subroutine down here, and the subroutine redraws the borders.
Okay.
And if that doesn't happen, if that value doesn't get less than 1, then we subtract. Oh, it could be because it's equaling 0.
Oh. We do 0 or 1?
Yeah, right. Less than or equal to 1, maybe. We'll have to play with it and see. And if that doesn't happen, then all we do is subtract the joystick value, which is 4 or -4, depending which way we're talking, from the row, and then it redraws the sprite down here on line 10,060. So that could be it. So let's see. So let's just kind of run through the logic. If we're at 104, and we subtract 4 at a time, boom, 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 right? Mm-hmm. We're eventually going to get to 0. Or actually, we're going to get to 4. Let's say we're at 4.
Yeah, it's a good number.
Well, yeah, so let's see. So if the row is at 4, and then we subtract 4 from it, that's less than 1. Okay, I don't see what the problem is, though. It's less than 1, and so we immediately set the row to 184. We change the map value. We redraw the borders.
Yeah, because 0 is less than 1, so why is that happening? That should go all the way down to an even 0.
And then if, well, yeah, the leftmost position isn't 0, it's actually 1. I think. Actually, let me look at the let me look at the call sprite documentation here and see. Maybe I'm wrong. Maybe it starts at 0. That could be. Maybe I just have it. It's probably something super simple like that. I mean, it's just. Let's look at call sprite and see what we can find out here. Sprite. Okay, yeah, so it is 1. The lowest value is 1 to 256. And we found we had to adjust it a little bit because of the width of the sprite itself for it to look right. But none of that seems to be explaining why there's a problem. So
Yeah.
So let's say we're at position number 8. So we take the row is 8, we subtract the joystick value, which is 4. That's not less than 1, and so we immediately subtract 4 from the row, and now we're at row 4, and we redraw the sprite, no problem. And if we're at position 4, the row is 4, subtract the joystick value, which is 0. 0 is less than 1. So we should immediately change it to 184, which is as expected. Change the map value.
Not working in direction anymore.
Let's paste this. Let's see, we have the version that works loaded up here, right? So, oh wait, no, which one's? Let's see what we have loaded up here. Yeah, this version works.
Yeah, the one.
So let's mess around here for a minute.
Okay, my love, we're heading out.
Oh, you taking off?
Yeah.
Have a good time at dinner.
Thank you, Mama.
I love you.
I love you.
I'll see you when you get back.
I'll see you when I get back. Did you want me to maybe pick you up like a sandwich
Yeah,
or something
love it.
from Safeway?
How do you say no?
Okay, I will pick you up something. I know what you like.
I love you.
Okay, I
I'll
love
see
you.
you in a couple
See you in a
hours.
little bit.
I love you.
I love you.
Okay, so this version is working fine,
Yeah.
but we may be able to see where we're lining up here. So to me, it looks like I wonder if there's no problems. It's everything's working here. So I wish I could zoom in and highlight the pixels so I could see how many pixels off we are, but you know, it just doesn't seem to. But okay, so this version works. So let's which line number are we talking about? We're talking about line 60. So let's just make the change right here and see how could this possibly make a difference? I just don't understand. Yep, so that's there is some problem in our let's go back to here. There's some problem in our logic. What is the problem?
It goes even. That's an even break.
Because this call joystick routine is only being called once, and then it moves on. So even if you're holding the joystick down, it only registers it once. What happens if we do like? Well, it wasn't even lining up anyway. So let's see if we can figure out how off we are. Let's change this back to 100. Actually, no. Let's leave it like this for now. Let's run it. It wasn't even like these. Ignore the numbers because they don't line up. I just put them in an arbitrary position here. So how many pixels off are we? Looks like maybe 1 by 1, doesn't it? We need to go.
103 instead.
Actually, I think it's the other way. I think it's 105. We need to do 105 and 105 probably. Oh no, we're at 100 still, right? Hold on, I forget where we were. So many versions of it. 104. Yeah, so let's change this to 105. I mean, maybe just this will magically fix the problem, and it doesn't matter what the problem was because we're going to make sure it falls in line with a grid position anyway.
Yeah.
This maybe we don't have to solve the problem to solve the problem. Okay, this lines up now. Look, everything lines up nicely. And happily, it doesn't break things anymore.
You go through any door?
Yeah.
Nice.
So look.
Yeah, there you go. That's way better.
It is way better. We just need to make sure we can't go through the doors now.
Yeah.
Okay, well, at least changing the start. As long as we keep it aligned like this, and right now it's moving by 4 pixels at a time, which is working okay. It feels pretty good. Maybe it's a little slow, but maybe it's a good thing that it's a little slow.
It looks kind of perfect pace for what I had in my head.
Yeah, me too.
Like the trail I've been talking about, like that little trail behind the block.
Mm-hmm.
The speed would look perfect.
I'm not sure how to do that. That might be a nice to have thing.
Yeah. Oh, definitely. Yeah, I think any kind of animation.
So again, I know we just tested this, but I don't want to take for granted that it works. So let's do this. Run. Yeah. Okay. Well, that's good. Well, that's good. All right. Let's go back to this now and see if we can figure out how to make it so you can't walk through the walls. So, I think, let me think how to do this. One way would be to, before we do any of this movement, we could say, if you pressed left, we could then check to see if, check the character to the left and do the same for all 4. Check, if you press left, then check left. If you pressed up, then check up. If you pressed right, then check right. If you pressed down, then check down. And then we could have a variable that's like something like movement allowed. And if movement is allowed, then run this code here, all this movement code. And if movement is not allowed, just circle back until you that would work. Just circle back until you do a movement that's allowed. If you can't go left, then it won't let you go left. Circle back until you move somewhere you can go.
Yeah.
Or we could build it in here. We could say, I think, but that's going to be this is already a long line, and I want to keep I don't think if we lengthen it, we're going to run out of character space in Extended Basic, because you have a max number of characters per line in Extended Basic. So I'm leaning towards doing it the way I just mentioned.
That sounds like a good spot to start.
It does. So let's just try it here. So we'll renumber everything in a minute. So at this point, we've checked the joystick value. We know the player character, so this should give us all the information we need. So we need then to just thinking this through, like we're going to need to know let's define variables for the four directions. So let's say we have oops, my capital's on here. Oh. Left character equals right character equals, and at some point I'll probably want to go through and shorten these to smaller variable names, but let's just get it working first, and then we can go through and make it efficient. Because once each section of code is working, we can probably leave it largely as is, because these are really kind of like our functions in Pico 8. This subroutine is fairly autonomous, right? You go into the subroutine, then you're out of the subroutine, and you're doing other stuff. So up care equals, and I'll fill these in here in a second. Down care equals. Okay. So what does the left character equal? It should be the column number, except it's weird because we're at 105. So let me think how this works. I think it's a matter of I'm for some reason I'm having a hard time visualizing this. So you've got a grid of characters, and so 1, 1 is the same in both sprite position and the character position. Where we start to get different, so let's say we have 2, 1 or 1, 2, row 1, column 2. So we're, in terms of the character, that would be position 2, but that sprite in the same position would be at position number 9 now. Right?
I think so. Yeah, I wasn't sure if it would be 8 or 9 or 16 or exactly how it works. But yes.
So I think what do? Do we subtract 1 and then divide by 8? Does that sound right? Well, let's check our work here. I'm going to get a piece of paper out. It's part of the fun of doing this stuff, right? All the weird math you have to do.
It is. It's so cool.
So
just some words, some math. You can create a world.
So if we're at position 105 in terms of pixel values, that's our starting position right here. So if we subtract 1, so I know you can't see what I'm doing here, but I'm writing subtract 1. And that equals 104, then divide by 4 equals, and I'll get my calculator out here. I could do it in my head, but I'm not inclined to do so at the moment. Position 26. Okay, so that at least gives us an even value. Let's just check our work, though. Let's say we're at position 1, 3 in terms of characters on our grid. Let's get back to where we were here. So let's say we're at position 1, 3 right here. What would that translate to in terms of sprite value? So that would be, because the leftmost would be 1, 1. The one next to it would be 1, 9 we figured out. So, and then add 8 to that would be 17, right? So 1, 17. So now, if we subtract 1, that gives us 16. Divide by, wait, not divide by 4, divide by 8. That's not right. Okay, so something's not right here. I know I'm probably seeming like a dunce here. I don't know why I'm good at math. I'm just having a hard time visualizing this. So sprite equals 1, 1. Character equals 1, 1. Okay. Now to the right of that, sprite would be, we'll come up with the formula for it here. I'm probably reinventing the wheel, but that's okay. Someone knows this already off the top of their head. It's just not me. So sprite equals, let's say, so the position over right here would be row 1, column 9, because the characters are 8 pixels wide.
Yes.
and the character would be 1, comma 2. Okay. So let's just see, the one to the right of that would be, sprite position would be 1, comma 17, because they're 8 pixels wide, and the character position will be 1, comma 3. Right?
Yes. Yes, I think so.
So I need a formula that gets me from 17 to 3, and then works in all cases here. So
It always adds 8.
yeah, but I can't just divide by 8. You know, it's but if I add 7 pixels and then divide by 8, plus 7 divided by 8, that gets me to 3. So let's see if that works now. So the next one over would be, the sprite value would be 1, comma 25, right? 17 plus 8. And then the character value for that position will be 1, comma 4. So if I add 7 to 25, I get 32 divided by 8 equals 4. There's my formula. Got it.
Wow. That's so crazy. I love how your mind works.
I'm glad you love the way. Sometimes my mind is exhausting, I'll tell you that. So I wouldn't envy my mind too much.
Yeah.
But we figured it out.
I hope I don't seem like a dunce, and I'm like, I don't even know how you're comprehending this.
Well, you know, I do have a good visualization of it. I'm not good at spatial relationships so much, but I can visualize stuff pretty well. So numbers I can visualize, you know. Okay, so now we kind of know what to do. So this is going to be an interesting challenge because we're not talking about the character itself. We're talking about several pixels to the left. So the left character to the left is going to be, we're talking about the column value. So soc row. Plus 7 divided by 8, but the character to the left of that will be 8 pixels less than that. So all of that actually one character to the left minus 1. Right? So we take the column. I meant column. We're talking about column. So take the column number, add 7 divided by 8. That gets you what character value you're at. But we want the one to the left, so we're talking about one column to the left, so we then subtract 1.
Okay.
And this is
Does it
not...
need to be like some sort of addition or subtraction or something between the left character and the so-called thing?
Well, what we're going to do, so first of all, we're going to figure out what these values are for the left character, right character, the character to the left, the character to the right, the character to the north, and the character south. Then we're going to use this command called gchr, which gets the character value for a specific spot on the screen. And then we're going to do a comparison and see if that equals a wall value, a wall character. Then we're not going to enable the motion. If it does, and if it does equal the wall value, we're going to disable the motion. And if it does not, then we're going to allow the motion for now. So I think this is not all going to fit on one line. So I think we need different lines here. Oh, this should be equals. There we go. That's better. Okay, so now we need to do the same thing.
Wow, that was so cool.
What's cool?
That formula you just created right there.
Thanks.
To me. Cool to witness and comprehend it.
So the character to the right just needs to be +1 now.
Yeah.
I'll redo these numbers here in a minute. Okay, so now, but we're talking about, if we're talking about up and down, we're talking about the row, not the column. But the formula should still hold, I believe. We
Yeah,
just,
it makes sense. It became square.
so if we're talking about going up, we're taking the, that's analogous to going left. So we're going to take the row number, do the same formula, and subtract 1.
Cool.
I think. Yeah, what's funny is that I think sometimes I come across as confident when really I'm just trying it out, and if it doesn't work, oh well, you know.
It's cool that you can be able to think this way and come up with the things that you did. Yeah, that formula. Yeah, it's just crazy. I don't know. It's hard to conceptualize whenever you know, you do this stuff. But
Yeah.
someone who's so out of the field, it's like I'm over here like, why? It's like I never knew what to do with math. And look at you over here. You know what to do with math.
I was always good at math. My first goal was to be, my first professional goal was to be a math teacher.
Yeah, I always loved math. I was really good at it. That's why I think I understand this stuff so well, but I never knew how to practically apply it to creation, really. It was like, oh, I understand this stuff, but I don't know what to do with it. You're doing something with it. It's really cool.
So let's see what else we need. Now we need to get the character values. I'm probably doing this. I feel like I'm doing this the long way, but that's okay. Let's get it working, and then we can make it more efficient, maybe.
Yep.
So let's get the character values for all the immediate. Because this is going to give us the wait. Oh wait, yeah, we need the left character X and Y. Okay, so hold on here. I'll fix the line numbers in a minute here. Let me think. So this is going to give us, we're talking about the column, so this is going to be the X value, right? And this is going to be the X value, because we're talking about left and right. Oh, actually, left character, not X value. Let's do column, right character column, up character, this is going to be the row, right?
I think so.
Mm-hmm. We're talking about the row, which is vertically, so we're talking about which row we're on.
Oh, I think I'm starting to comprehend. Yeah.
Okay, so, so if the column, if we're looking at the column to the if we're looking at the character to the left, we're talking about the column to the left, but the row is going to be the same. So the row is just the same formula without the -1 or +1.
Yeah, because they're not moving in that direction.
So left char row is just going to equal this little formula. And left character, or sorry, right character, if I can type today, right character row is going to equal this formula. It is fun to make stuff, you know, it's amazing what the human mind can do, you know. I mean, this is still baby stuff, but, you know, we had a problem and we solved it. Or at least we're mostly solved it, you know. Okay,
Yeah,
so
okay.
up char column equals this formula right here. And, oops, down char column is just going to equal this formula right here. That should give us what we need to do the comparison. Okay. Again, I'm for people, I see people watching, for people that are watching, I'm fixing the line numbers after the fact. We were just trying to solve a logic problem, and then we're going to renumber this. So yeah, we know the numbers are inconsistent at this point. Okay. So now we need to get the, and there might be a more efficient way to do this, in which case we'll figure that out after the fact as well. I just want to get it working first. So we need to get the character values for, now that we have it looks like arrow. Left caret row, not left caro. Now that we have the row and the column positions for all the characters surrounding our sprite, we can get the values using called GCHAR function that will tell you what characters are in those slots, essentially. So call GC, and I've seldom used this in the past because I haven't done this since I was a kid. So what does it do? Call GCHAR you tell it the row and the column, and that gives you a variable. Right, and so we need to figure out, whatever it is, we're going to get the value of it. So basically, if we're here, we're going to do call GCHR, and it's going to give us the adjacent, the values for the adjacent slots in the character grid. Then we're going to check to see if they're a wall character, and the wall character is, what do? We just did a 32, I think, right? Yep. So the walls, the borders, are character number 32, I believe. Wait, I think. No, 96. 96. That's the one we defined as a. Yep, right here, 96. So we just need to check to see if those are 96. And if they are, then we allow the movement. And if not, or if they are, we don't allow the movement. And if it's not 96, then we allow the movement.
Yes.
Okay, let's. No, it seems like a lot. It's such a simple program, but I think what we'll have accomplished after this, we'll be able to move around the entire map. We'll be able to go from map screen to map screen, and you won't be able to walk through walls, only through the doors. That's actually a lot, and not too many lines of code.
It is.
And we'll be able to make it even more efficient, I think, once we get it working. So call GCHAR. So we need. We said row, what is it, row and column? I always forget. It's because it's not. You think in terms of x and y's if you've done math, but row and column is actually y comma x. It's so annoying. So it keeps messing with my mind. It really does. Yes, row column, which is y x, and then so yes, row and column. So call GCHAR. So we're going to have left char row, comma left char column, and again we're going to go through and make these variable names shorter eventually, but let's just get them working, and then we can go through and once it works solid, we can go through and replace them with single letter or two letter variable names for the sake of memory efficiency, which is going to be at a premium. So let's call it left char value. Sound good? So this is going to say go find the character at these two values, the row and the column, and give it the variable name, whatever character number, character identifier is in that slot. Give it this variable name, which we're then going to use to do some logic to see whether we're going to allow movement or not. It's so fun to be working in this old system. So right char. Yeah, I am in my element. It's funny. Wait, right care row. That's right. Okay. Comma, right care column, comma, right care value. Oops. G care for get character. So that what that stands for. And we said it was up care row, up care column, and we're going to call this up care value. One second here, I just got an Uber notification. Ooh, Auburn to the airport, 1240. I'll take that. That's extra money. My sister's actually paying me to make a website for her right now, so I haven't been doing any Uber driving this week. I've been building a website for my sister.
Cool. That's awesome.
Yeah, she has been hosting her teaching videos, not her teaching, but videos that she uses for teaching her music classes on this website that it's cool. It actually prevents you from showing ads on YouTube. So YouTube videos, but hides the ads. But the school has blocked that website for some reason, that's insurmountable. So she needs these videos hosted on a website and categorized, and she's not going to worry about the ad blocking. It's just not that important apparently. But there's something like 1,000 videos. So it's an interesting challenge because you can't just embed 1,000 videos on a single page, or even more than 10 or 20 videos on a single page without completely clobbering your browser. And so what I decided to do, rather than build her own website, build her a subsection of my existing website that has some YouTube video playlist features already built into it. And so yeah, I've just been basically building her a few pages on my website with this video embedding features built in, because it automates things like not showing you the entire playlist, just giving you a thumbnail of the video, so it loads efficiently and works really well, better than I could build myself from scratch. I started by building a website from scratch and quickly discovered that was not going to work. That it's a total memory hog and would clobber the browsers. But yeah, so I've been doing that all week for her, and she's paid me $1,000 to make her a website. So very cool.
That is so cool. I might have to hire you someday too.
I can do it. It's more and more I'm finding there's a lot of people out there. You'd think in this day and age everyone would just build their own things. It's really people just don't have time.
Mm-hmm.
Like my sister could do it. Yeah. She just doesn't have time. It's taken me a week to categorize 1,000 videos. She doesn't have a week to do it. So let's see, so down character row, down character column, and we're going to call that down character value. So far, so good.
Yeah, I like it.
Okay, so now, let me think. If so it's a little confusing actually. So we say if what do we want to say? If the left character, if the joystick value is such and such, which is if we're talking left right. I should have done joystick row and column, but that doesn't make sense with the joystick. The XY actually makes more sense. So you can see why certain things got improved in terms of language programming. Some of these weird gestalt shifts you have to do between row and column and X and Y. It's just like, okay, it worked, but it could be made more consistent. Almost every modern language is better at this than this. Okay, so let me go to my called joist part of the book here. Right, okay. X and Y. So if the So if we're moving left, the x value is -4. Okay, so let's check left first. If joist, and we said x, right? Yep. X return, Y return, -4, 0. So, yep. So if joist x equals -4 and left care value equals we said 96. Then, so if we're moving left and the value is 96, then let's just call this movement allowed, or allow movement. Allow move, that works, equals 1 or 0, right? So if it's left, but the left character is 96, we want to say don't allow it. Allow move equals 0, right?
Yes, I think so. Yes.
Else allow move equals 1. And we're going to check that for all 4 directions, right?
Yes.
Which is weird because, let me think, because we could do all 4 at once, but then we're checking a bunch of stuff that's not necessary based on the direction you want to move. So maybe we want to stagger it. So we check to see if movement is allowed left, and then we do the routine down here that controls moving left.
Mm-hmm.
But that may not work because then we'll have to check. Because yeah, maybe we do need to check all 4 directions, because say we move left and then we allow the movement. When do you circle? Yeah, again, I think we could. Let's just get it working, and I think we can make this more efficient. I think there's probably a better, way more efficient way to do this, probably. So let's say if joist x equals 4 now, if we're moving to the right, and right. Oh, yeah. Typos abound. And right care value equals 96. Then allow move equals 0. Else allow move equals 1. You know, it's funny, even if we run out of memory to do this game, I would just be so impressed that we made this work. This is the kind of thing that once you build this, you could use this for 1,000 games, you know?
Yeah, exactly.
This is a great little system we're building here. So if joist... Oop, now I got to be careful because I think the Y values are what was weird here, if memory serves. Yeah, so up is positive here, but that actually corresponds to a negative row number because you're going upward and the row number is going down. And so the Y value is the one that's inverted in a weird way. So if joist Y equals, let's talk about going up, equals 4. Keep it in the wrong screen. There we go. Equals 4. And up care value equals 96. Then allow move equals 0. Else allow move equal 1. This is such a fun journey. I'm so glad we're doing this together.
Same. It is really fun. Just over here, like flabbergasted.
Part of me, I feel kind of bad because I feel like to some extent, I'm feeling like I'm doing all the work here. But you're going to do such awesome things with graphics. That's just it's all in my head.
Mm-hmm.
You're going to make this game look better than I would make it. So
Definitely gonna try. I'm gonna give it my all.
yeah, we can towards the end maybe we can spend a little time just talking about the aesthetics of the graphics, and I'll show you a couple examples
Yes, that would be good.
so you can get started actually just sketching stuff, you know.
Yeah, once I do the first thing, if you don't like it, you can be like, oh, we want it more detailed, we want it slimmer, we
Mhm.
need to be thicker, this is too detailed, or whatever you're feeling about it.
I have
You can change it
I
up.
have a suggestion for how you might get started working on the graphics. So
Okay, cool.
we'll talk about it here in a minute.
Ideas that you had, but most of them, since it's just like generic things, I figure I don't really need to draw it out. It's like, yeah, just do one that's sliced it in half. Let's see, but I figure if we go page by page, map by map, like if I can make the map and then go like each dialogue by dialogue,
Mm-hmm.
draw it out step by step as we're progressing through the game. I think that's where I'll have to spend this time. Like the first world, I knew I needed to draw the map.
Mm-hmm.
Because I know what we want to play that first little space that he's in, or Socrates that he's in, and where we want to go next with those cool little spaces that we, I think I can start creating those pretty swiftly and have a bunch of different ideas to try out.
It's going to be so much fun. It's going to be great.
We could start creating the first few things, and I understand the mechanics even better. It'll be even easier for me to keep moving with it. But right now, it's like, where do I dip my toes in? I'm not.
Yeah,
really
I think
sure.
we just need to start. You just need to start with some one asset, like draw a temple or draw something on the inside of Socrates' house, or just start with something. It doesn't matter what it is. So let's see here. So let's see what we've got. Right now we're getting the character values for all of the positions up, down, left, right from where your character is at. We're checking to see the joystick value and whether the character value is a wall or not. And then we determine whether we can allow movement or not. So I think at this point we can say if let me think. If allow move equals 1, then actually if it's 0, I'm going to skip the movement. I don't want to redraw the sprite at every single turn though, so it's like I got to figure out where do I skip ahead here. So actually, if allow move equals 0, we don't do any movement. So we just go to the end of the subroutine.
Yeah, that's the one that's, yeah.
So if allow move equals 0, then I think you can just put a line number, then 10,080. Else, go to the next line. Actually, we don't even need to put an else. It'll just go to the next line. Basically, if allow move equals 0, then skip all of this movement stuff and just skip to the end of this loop, which is at 1080.
And that sends you back up to the movement.
Yep, and just so this is what's looping and checking for movement.
Okay, so as long as you're going in a direction you're not allowed to move.
I think this will work as it is. Let's paste it in.
Yeah, you don't have to allow move at all. Oh yeah, because it is defined by a 0 there. And now all those.
Yeah, basically, if allow move is 0, then just skips, and then next loop it'll get new values for allow move, and based on what you do.
Yeah.
I think this will work. I really do. Let's just paste this whole thing in. So new, and did I copy it? I did, right? Let's make sure I copied it. Copy. Now let's come in here and paste for extended basic. Oh, we got a. What happened there? Let's run it. We got a beep. I'm not sure what happened. Bad value in 10,005. Why is there a 10,005? Oh, okay. Hold on here. Huh. Bad value. Okay. Oh, what's Oh, hold on. I've done a few things. Hold on. I see what happened here. Okay, this has got to. We need to renumber this.
Oh,
I didn't fix the numbering. Okay, that's my fault here. Okay, so let's just do. Let's start doing this by 10. We'll just do it right from the beginning here. Although I think we're probably going to have to tighten up these numbers once we've got everything working the way we want. Okay, we'll fix this number here in a second. So this will be 150. Yeah, people used to write programs on paper a lot more because it was such a pain in the ass to edit on the screen, you know. I remember my dad used to write programs we worked for Ball Metal Corporation. He used to have this graph paper with a pad of graph paper. It was branded for Ball Metal Corporation. He used to write programs in this graph paper from his company.
love that. Love graph paper.
Okay, so go to 10,000. That's fine, but this needs to be 10,000 to 10 now. And that's fine. The subroutine number is fine. Just collapse this a little bit. Okay. Well, let's see if that fixed the problem or not. Didn't get a beep. That's a good sign. I think it'll work. I do. Oh, we didn't break anything. We're moving. It's a little slower because it's checking more as we go now. So let's see here. Can I go through the door? Almost. What happened? Why are we getting a bad value in that line? Call GCHAR. Left care row, left care column. Why are we getting a bad value there? Let's This is an interesting debugging program. It lets you. Oh, that's too hard to watch. No, that's not going to help.
Yeah, that was really cool. That's a lot.
So where are we getting a bad value? So far, we're doing fine. Are we still lining up with the?
Yeah.
So right here, we're fine.
Can't go through it. Oh wait.
When you try to go through it, it's having an issue. What did I do wrong here? So it says bad value in 10,060 or 10,080. So it doesn't like these. It doesn't like these statements.
Yeah.
So let's go look at the book for call GCHAR again here and see if I just did something wrong. That could be. Okay. Oop. Okay. The GCHAR subprogram reads a character from anywhere on the display screen. The computer returns a numeric variable, the ASCII code for the character in the position described by the row and column. Row and column are numerical expressions. Value 1 for row indicates the top of the screen. Value 1 for column indicates the left side of the screen. The screen can be thought of as a grid as shown below. Okay, that seems clear. Okay, call GCHAR assigns to the variable x the ASCII code of the character that is now in. Okay, so that seems fine. That's what we have here. We've got GCHAR, left character row, left character column, and we're defining, and that's defining a new variable, left character value. Let's just make sure. I like that. One thing nice thing is it highlights, if you highlight something, it shows you where else it appears, so it's just really handy.
Oh, that's good.
Yep. So make sure there's not an obvious mistake here. Left char row, that looks right. Left char column, that looks right. Right char row. So far, it's looking like everything matches up. But why would we be getting a bad value? Must be a problem with our formulas. So I'm going to run this again. I want to see exactly where we're getting a problem. At least it's working. I mean, like so far it's checking, you know, we haven't broken the movement at least. But here we're getting a problem. So right here, ooh, boy, it's the performance is really slow. We're gonna have to improve this a little bit. I think I do need to improve the structure of those commands. It's checking too much. It's making it just me mind-bogglingly slow. Also, it's not instant response because it's doing like 8 lines of code just to move left.
Yeah.
So you have to like hold the key down for a second. We can work on that. Okay, so when I go left, okay, it's right there that it's having a problem. But notice it drew it and then it had a problem.
Yeah.
So why? Why would it that happen? It's because there is no position to the left. It's checking to see, when you're at the left. Yeah, okay. I think I figured this out. It's right here. If we're at position number 1, let's just say left character column. So we're at the leftmost part of the screen, right? Mm-hmm. Then we are at, yeah, okay, I think I know the problem. Okay, so left character column, 1 plus 7 is 8, divided by 8 is 1, minus 1 is 0. GCHAR does not like 0. That's the problem. Mm-hmm. So, what we need to do because you're at the leftmost part of the screen. It's then checking to see if there's anything what's to the left of the leftmost part of the screen, and it doesn't like that.
You do like else you're like unless you're in this specific position, then don't.
I think that's right. So we need to say, because we have the, do we have this, let's see, do we have this, we have the row and the column. We need the player character row and column. Player, our Socrates. Socrates character row. I know we're having a lot of variables. I knew we would.
Mm-hmm.
Soc char row equals right here. This. And soc char column is going to equal this right here. Right? Actually, it's funny, now that I've done that, I can probably dispense with all of this math. I can just say add 1, minus 1. Once I have the Socrates character value and its position in the grid, I don't need to calculate it every time. So I can clean these lines up a lot once I've done this. Okay. Right? Because I already have I've already done the math. I know exactly where my character's at now in terms of the grid, in terms of its grid space. So I can just I can get rid of this and I can say soc char column. Wait. Did I make a mistake here? I did. Yeah, look. I made a mistake here, I think. So the left char column is going to be, this will be easier to understand what I'm about to do, I think. Soc char column minus 1, right? So you take your Socrates character, which we just calculated, and subtract 1 from it. And the row is going to be exactly the same. Soc char row, not column, row. I made a mistake here.
Yeah. Yeah, the one below it too.
Yep. Okay, so the right character column is going to be soc char column plus 1, and the row is going to be the same because we're only, right? Yeah, that's right. So soc char row. This is so much easier. Okay. So sometimes you got to do things the hard way to figure out the right way. Okay, so soc row. So soc char row minus 1. And this is going to be soc char column. And this is going to be soc char row. And this is going to be soc char column. Okay, that's a little easier on the eyes. Add a little space here so I can visually see what's going on. I like that I can add extra spaces in here too. I'm such a visual person. The visual chunking really helps my mind not get washed over by the craziness of it. Okay. So now what do we want to do? I feel like I'm being horribly inefficient here about this, about the way I'm approaching this. I mean, I could just make more variables. Allow left move, allow right move, allow up move, allow down move, you know. So let me think. So the problem we're encountering is here. It's when I'm going to try something here. What if we do something like if sock care, let's see, we're talking about moving left, right? So if sock care column is greater than 1, then get the value. Let me pursue this line of reasoning here. If sock care column is less than, let's see, less than 32 columns across from a character standpoint. If sock row, talking about moving upward, so if sock care row is less than 1, then check. Okay. I think this will work, actually. Okay. I'm not quite there yet. Let me create some space here. If sock care row, hold on, I got some phone buzzing here. Who's messaging me? Oh, it's you. Are you back? Can you hear me? Hello? Hello, hello? Hello? Can you hear me, Dylan? I hear you. You look muted. You can probably hear me, I think. I can't hear you because you're muted. Your microphone's muted, according to the Discord.
Yeah, I muted myself because I still can't hear anything.
Oh, you can't hear me?
I'm back though, but I can't hear you for some reason. So I was gonna go into my phone's settings and stuff and see if like I need to allow something within my phone settings for the app or something. You know, I can find it from my phone instead of within Discord because all the Discord settings seem to be on. Like I should be able to hear. So yeah, my phone must be blocking it or something. So I'm just gonna keep myself muted until I can hear you.
No worries. Keep working on it. Okay. Let's see here. Let me think. Ah, I got it. Boy, it's a lot of code just for player movement, isn't it? Oh, it's going to be slow as molasses. I think this will fix it, though. So we get the joystick value, we get the player sprite position. We immediately turn that into a character position. Check, we get the values for the row and column for all the adjacent positions. If you're not already at the edge of the screen, then we get new left character, right character, up character, and down character values, because we may need to check to see if they're walls. And if they're not, if you're already at the edge of the screen, then we just set the value to 32, which is a space, and let you move like as if you're going through a door. And then we do all this other stuff. I think this will work. Let me just renumber this real quick. Hopefully, anyway. Nothing is as tedious as renumbering basic line numbers, like it's 1981. Oops, 200, 210, 220. This needs to be 220. I could probably clean that up eventually. Okay, I think this will work. I'm waiting for Dylan here. So we might call. He's looking for headphones. I think this is going to work. I hope this line isn't too long. This concerns me a little bit. I'm going to have to... save this before I forget here. In fact, I'm going to make a little improvement here. Actually, no. Leave that the way it is. so I don't make any typos here. Sorry for folks that are waiting on us here, just waiting to get reconnected with Dylan here. Oh, there we go, he's calling. Hello.
I give up. I don't know.
That's okay. Can you still see my screen?
Can I be on the call and be in Discord?
I think so. I don't know why not.
Oh yeah, I can see your screen. Yeah.
Perfect. I think I solved it. I haven't tested it yet, but I think I solved it. So let me walk you through the reasoning here.
Okay.
Okay. So we find the adjacent positions. Boom, 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 boom. Then only if you're not already at the screen edge. So if your column is greater than 1 or less than 32, or if your row is greater than 1 or your row is less than 24, then get the adjacent screen characters. And if you're already at the screen edge, then just let the character value, the left character, right character, up character, and down character value equal 32, which is a space. So it treats it as exactly as if it's a door, in other words.
Oh, okay, perfect.
Now, so then we allow or disallow the movement. If the left character value is 96, then allow the movement. Then don't allow the movement. Otherwise, allow the movement. If it's 32, then it'll allow the movement. So I think this will fix it. I haven't tested it yet, though. So let's do that. So new, and did I copy it? I always forget if I copied it already. Okay, copy. Oh, nope, forgot part of it here. There we go. Copy and paste for extended basic. Oh, I got a beep there. I'm not sure what happened. Let's list out the program here. I was worried about one of these lines being too long. Actually, let me see. I was worried about this line here, line 10,070. Let me list that out separately. Oops. All right, looks okay. Let's run it and see what happens. Syntax error in 10,080. Oh, missing a then. This is why we do this. Then. Else. Okay. Syntax errors. Let's try this again. It might have beat because of the syntax error. So far, so good. Run. All right, fingers crossed. We're moving. Let's check, make sure we can go through the doors first of all. We're moving. Nice.
Oh, nice.
Let's check all 4 doors. It's a little slow. I think I know how I want to fix that.
Nice.
Let's go right. I think we can just fix this by making it move for not just half a space, but a whole space at a time. Make it seem twice as fast. Nice, it's totally working. Check it out.
It is totally working. Are the walls working? You can't.
That's what I want to check next. Now, what happens when we get to a wall? Let's go left. Oh no, it's letting you go through a wall. Why?
Yeah, I'll let you walk right through that.
Oh, I know why.
At least there's no glitch.
I know why. I think I know why. Let's do that. Let's make it so you can't go half a space at a time. So when we move, we're going to go minus joystick Y times 2. And joystick Y times 2. This will make it so we move an entire 8 pixels at a time, as opposed to 4 pixels at a time. It'll move faster and it'll solve the problem, I think. Oops.
Perfect.
Okay. So now we should always be aligned with a character, which is part of that was the problem. I think we weren't actually aligned with a character, so it wasn't checking things properly.
That makes sense.
Yeah, sort of. Hopefully.
It was in the wall like it was. I thought that could be the issue.
Yeah, but then we moved over half a space before we tried to move over a whole space.
Yeah.
So I think that's probably the source of the issue. And it was moving a little slow anyway. This will make it feel like it's moving a little faster, so I think I'll be happier with this anyway. Wait a minute here. Wait, is this me or is it skipping over things? It is, isn't it? How come?
Try going over the 0.
Well, the 0 isn't lined up with anything. Bad value in... this is harder to make work than I thought it would be. Why would it possibly... It's so weird because before we had this times 2 in there, that's the only change we made. Oh, I gotta take out the times 2. There we go. It was moving 4 pixels at a time, and I wanted to double that to 8 pixels at a time, but then it was skipping over an entire character.
Or it'd be +4 instead of times 2.
I don't know why, because these joist Y and joist X values are always going to be either 0 or -4 or -8 or +4. And I wanted to make them 8, so you move 8 pixels at a time. So I just times it by 2. Something doesn't make sense about that. Let's try this and see how we do. New. Paste. I would really like to solve this problem by the end of the day. Yeah, see, look, we're moving by half a space at a time. Why? Oh, no, now we're moving at a whole space at a time, right? Yeah.
Yeah, that does look like a whole space, actually.
Okay,
Yeah.
so we should be able to go through the... Oh, but now look. Oh, now we're offset. Ah, okay, I know the problem. It's where we're redrawing it after we go through the...
Ah, that makes sense.
Yep. It's this code right here. Well, actually, let me stop it and start it again, because now, before we go through before we change rooms, it should work fine because we're lined up properly.
Yeah.
So now let's check to see if we can go through a wall, and we can. So something's still not working right. But when we redraw the character after changing, so we did, it was divisible by 8 plus 1. So where do we, let's see, we need to, where is it? Right here. Calculator time. I guess I can pull up a calculator on my computer. In all fairness, everyone can see what I'm doing. All right, so 184 divided by 8 is 23. So what is the problem here? I wanna run it again here real quick. Where are we having the problem? In other words, when do we get out of alignment? So if we go up, we get out of alignment. We figured that out, right? Boom, we're not lined up anymore. Okay, so let's run the program again. What about if we go down? Does that line up correctly now? Okay, that does. So it's all up is causing the problem.
What about left and right?
Yep, I gotta check them. I'm gonna check them independently here. Just run it every time.
Cool.
If we go left, okay, that's out of alignment. We're off by half. Look.
Half when we go left or down so far.
Mm-hmm.
Yeah.
Okay, and now let's check to the right. So up and left, I think the ones where you have to force not, because when it sets to 1, it's no problem. That's why it should work the other way. If we go right, it's not going to cause a problem. It's going to set us to 1. I just need to up the number. So this is. Oh wow! Look, it didn't even. Okay.
Oh, but yeah, then you went left. What if you go back to the right now? Does it realign you up?
Well, hold on. One thing that's weird to me if we go to the right, when is it bumping us over? It's actually, you might think it would happen not here, but after I'm in the middle of the room, after I'm in the doorway. But no, when I hit right again, and this one lets me be in the doorway. So we've got lots of problems here.
Yeah, and on the right side, you can't go into the doorway for some reason. What about when you went up? Could you go into the doorway when you went up? You're definitely going in the doorway in the down and left.
Yeah, I don't think so. But so if we're going to the right, that means if we're talking about the column, if so, if sock column plus joystick X is greater than, so this needs to be not 248. This is kind of strange because it's I'm just going to try this. I think I might see the problem here. Oop, helps if I paste the program in. It's fun to make things work right, huh?
It is.
It's frustrating until it, now, wait, is it moving at a weird rate again? Oh no, it's okay. Okay, there we go, look.
Oh, nice. You're in the doorway now. Nice. You're lined up.
Okay, so it still
Yeah,
pops
they're on
us.
the left,
Yep, so top and left is still having an issue. But one problem at a time. Let's run this again.
The left?
Do what, sorry?
I thought it was the bottom and the left.
I think the bottom works fine because it pops you up to value number 1, which is exactly where it should be. So I think going down works fine.
Oh, yeah.
Hold on. But can we get in the doorway for going down? Because it seems like you should get in the doorway, right? You can't. Same problem. So we need to. So I think what we need to do is right here. This needs to be. We increased it by 1. I think this needs to be 185. And we'll worry about we'll worry about where it pops it out next. Let's get it working right first, then we'll worry about where it throws you. One little fix at a time.
Mm-hmm. Bug by bug.
Yeah, exactly. So far I'm impressed though. I mean, you know, it's working a little slowly, and that's part of the problem with basic games in general. But I think there's ways we can probably speed up some of that code that I did the long hard way. And if not, there are people I can talk to in the TI community who can probably help me a little bit. So the problem is going down, right?
Yeah.
Okay, there we are, in the doorway, and then down. Oh, and then we're back at the top, right? Actually, wait a minute. What happened here? Hold on. There was a weird issue. So what's weird is there are actually more lines off the bottom of the screen. So I think what's happening here is actually it's moving us off the screen. Oh no, it's okay. Okay, so it's right there that's causing the problem. We need to decrease that number or increase that number. Okay, so when we go northward, which is decreasing the row value. So if the row value, column value, no, the row value. Right, we're talking about y. So if the row value is less than 1, this formula is less than 1, then this needs to increase. And it wasn't just by 1 pixel, it was by like it's about like 5 pixels, like 189. Let's try it. Just guesswork. That's okay. Make sure I grab the entire bit of code here. See how we do. Okay. Ah, there it is. Look.
Nice.
Okay, that fixed that problem. So now we're nice and lined up. If we go right, we're fine. And if we go left, we're not. And it was 5 pixels. I think we're off by 5 pixels. Yep, there we are. 5. It needs to go 5. Increase by 5 pixels. So if we're going right, I'm sorry, going left, then this needs to increase by 5 pixels. So 253. Pixel perfect. Don't ask me to explain it. So new. Okay. Paste. So now we should at least line up all the time, and now we need to figure out why we can't go through the walls. It's not checking something properly, or why we still can go through the walls. So if we go up, we're nice and lined up. Check it out. If we go down, we're nice and lined up.
Perfect.
Still moving a little slow for my taste. I'm not sure. That's why I think I just need to make that code a little more efficient. It's working.
Nice.
But we can still go through the walls, so something's wrong. It's not doing something it should do. What's the problem? I suspect the problem's right here. Because the doorways are being drawn with character number 32, right? Yeah, okay. So let's just assume we're at the leftmost part of the screen. So the column is number 1. right? So, and the sprite value, the pixel value, should be number 1. So then we want to figure out which column we're in. So the column is 1. We add 7 to that, divide by 8. That's our little formula we settled on. So 8 divided by 8 is 1. So the character column, which is the spot in the grid, should be column number 1. Then we come down here. If character column is number 1, wait a minute, actually, let me think. So then 1 is, yeah, hi Odd, how you doing? We're working on, maybe you can help us even. We're most of the way towards being able to navigate our around our map. We got everything lining up properly. We haven't been able to solve the problem of why we can't walk, why we're still able to walk through the walls. So we're working on, there's a problem in our code somewhere, but it's mostly correct. Oh yeah, but we're editing this in Sublime Text. So let's see. So if you're in column 1, then it's false that the column is greater than 1. So you're thrown over here, and it gives you a left character value of 32, which is fine, which is what allows us to move. The problem is right here. Oh, there's nothing, well, yeah, okay. So, and then if it's greater than 1, oh, you're in a game? Yeah. Hopefully we can get this working by then. Yeah, take your time. We're just head down trying to solve this problem here. So let's say you're in column number 2, which should be immediately to the right of the wall, right, Dylan?
Yes.
Okay, so if you're in column number 2, let's just see here. Okay, so if you're in column number 2, sock care column, if that's 2, then the left character column would be column 1. Okay. Then, if sock care column is greater than 1, because it's 2, our character's at 2, then we get the character to the left care column, left care row, left care column. That gives us left care value, which should be either a space or a wall, 32 or 96. And if we're at space number 2, then the left care value should be space number, whatever, in column number 1, and that should give us a wall, which is 96. Otherwise, give us 32. And now what's not working about that? So if we move to the left, if joist x equals -4 and left care value equals 96, don't allow the movement, otherwise allow the movement. I just don't see a problem. Everything looks like it should be working fine. What's the problem? Do you see any problems that I'm not seeing?
Mm-hmm.
I mean, let's just check to make sure. Left care value, right care value, that looks right. Up care value, down care value. Okay, those all match. If we're disallowing the movement, we skip the movement code. I don't see a problem. But yet, there is one.
Yeah, it's hard because it doesn't even give us a code or anything. It's just like,
Nope. You just,
didn't
it's all
do it.
guesswork.
It's just going right through that wall. And that's for sure 96. That's
I'll double check.
all I could think of is like, it doesn't understand that that's 96 that we're trying not to, that's it's not allowed.
Yeah, I mean, because if you look at the code that draws the walls, right here, draw the borders, the border is, so this is row 1, column 1, character 96, repeated 32 times. That gives us the top. Then that's row 24, which is the bottom, column 1, character 96, repeated 32 times. That's what gives us the bottom. Call VCHAR, same thing, character 96, 24 times, character 96, 24 times on either side of the screen. And then we draw the doorways. And the door, if the bottom door is if the bottom door is 1, then we draw a doorway, and the doorway is character number 32. So I don't think that's the problem. It's certainly looking for the right things.
Yeah, because it doesn't seem to be registering that it's running into 96 at all. Or doing anything. Yeah, it's not. Yeah.
I mean, it could be that it's not calculating the Socrates character column correctly. You know what I'm going to do? We're going to add more debugging code here. We're going to see what numbers we're working with and what's causing the problem.
Okay.
Oh, I don't know. Row 10, comma 11. No, row 11, 10. There we go. Let's call this sock row sock column. Sock row sock column. Display at 12, comma 10. Sock character row, comma sock character column. Okay, this should make it a little easier to see what's going on here. Because I think it's got to be, everything looks like it should be working. It's not checking some, it thinks something is not what it is. Because the logic looks, to me, looks pretty solid. So let's paste it in here with the new debugging code. Old school debugging code, you know? Oh, okay, hold on. I gotta make this a little easier on the eyes here. Let's fix this. Let's change this to three. No. column 3. There's not much room to work with. There's only so many characters you can fit on a screen. It's even, I think it's even worse than in Pico 8 that way in some ways. In some ways it's better than Pico 8, in some ways it's worse. All right, let's see this now. Okay, so this is going to be a little uglier on the eyes here, but we'll have more information to work with. Okay, so map position is 0, 0. The Socrates row, Socrates column is 105, 105. Now the character row and character column is 14 and 14. That looks about right. We move to the right. Okay, that's so far so good. The column position is changing as I move to the right. See that? Takes a second for it to update, but it's working. As I go downward, column, yep, moving up. The column is moving up by 8, and the character column is moving up by 1 every time. So far, so good. So when I come down here, okay, I'm at character column 23, that's right. And now if I come down here, okay, let's get even more information here. It's a little tedious and it's making it run even more slowly, but
Very cool.
display at, in fact, I'm going to make this 2, I think. Okay, so now we want left char value oops. I know this is super tedious to include all this stuff in we're going to take out, but it'll just let us see exactly what it thinks the values of everything is, you know?
Mm-hmm. I think it's really cool you can do that.
I mean, you could have done it in Pico 8 too. There's nothing really new here. It's just
Super neat. These new ideas.
this 2011, 12, 13, 14. We're going to give ourselves as much information as we can to work with here. Up char value. Down char value. Okay, now let's see how we're doing. Save this. New. And paste. It'll be even slower, but at least we'll be able to see at any given position what it thinks everything. We see if it is doing all the calculations correctly here. Okay.
is that one flashing like that?
I don't know. Not sure. So left
So what
here.
it's trying to say there.
Oh yeah, look, the character values are all screwed up. Look.
14?
Oh no, it's because we're next to some text. Let's get outside this text here. Okay, this now everything should fall in line.
Oh, I see.
Each character has a different ASCII code value.
Okay.
Okay, so we're at map X, map Y. That's right, we haven't changed maps. Row and column from a dot value, pixel value. That looks about right. Character row and column, that looks about right. Row and column 814 looks about right. There's 32 spaces on all sides of us now. So that's right, 32, 32, 32, 30. So it's definitely calculating that correctly. So that's good.
Yes.
It's interesting how to see what it's all. Okay, so now let's go up here. Let's go near a wall and see if it thinks a wall is next to us. It does. Up character value is 96.
Wow.
And if we move here, up character value is 32. Now let's
Why
just
is that stopping you? Why is it allowing
let's
you to
just
move?
check it all the way around and see what. So far we're most of the way there. There's just something not working, you know.
Yeah. You
Well-
can go in that wall though.
That's a good question. Now, when we go up, it should think that the up value is a space
Yes.
because I told it to do that.
Right. And the right character is 96. Cool. Yeah. So yeah. 'Cause
Yep.
you shouldn't
So,
go in the wall.
That tells me that the problem is in our movement code, not in these calculations.
Yeah. So,
It's awfully slow, and I do want to make this work faster.
It
but-
is registering 96. That's so cool. It's so cool to see it like that.
Right value is 96. There we go.
Yeah.
Okay, so now we should have spaces. There we go. I don't know why that one is flashing. It might just be an artifact of the emulator we're on. It might be. It shouldn't be refreshing, although it is running the code every time. I suspect that they're all flashing. Just one of these is visually causing a flash that the other one is. I'll have to look into it though, because I'm not. It seems weird that it's doing that. So
Putting that other number on that line for some reason.
I was noticing that. Yeah. Okay, so if we hit right. Up character value is 96. The right character value is 32. So that looks fine. Now if we wait, what happened here?
Where are you?
Oh, there we are.
I was like, I don't know where you're at.
Yeah, it's funny. It's actually a little hard to see. It's funny.
Yeah, and I have an idea already to make those walls look different.
In what way?
To kind of put like a little ledge on the top one
Mm-hmm.
to where it's like a 3D little wall, maybe even like a column, and then the bottom one would just have like a hard line and not have like a little wall, so it kind of looks like you're walking through a doorway. But
Oh yeah, actually, it's funny you say that. Maybe we put. How about we put vertical stripes on the vertical ones that looks like Greek columns, and then something a little more. Make it look like these ones on the vertical ones are Greek columns.
Yes. It's hard to describe exactly what I was thinking, but
Well, if you can draw it, I can tell it to do that.
yeah, it would look like, I'm thinking I'll have it look like a column, and then maybe just do like a little cool little design on the top parts where it's at the top, so it look like you're looking at the top of it. Yeah, and as I'm talking about it, I'm developing it a little bit more in my head too. So I'm feeling pretty cool about
I think
that. But
it
also
was.
is going to be like pixels, so I only have so much to work with also. But I do think I have an idea, and I have to layer the colors one at a time. It's just going to be white and maybe black or something, white and gray or white and black probably.
Well, so far all the math seems to be working great.
Yes.
I'm kind of spot checking it. The left value is now 96. So that is working. So let's see where we've gone wrong when the movement, because that means the movement, the only problem has to be right here.
Yeah, something with the allow and don't allow. Oh, I guess they're both allow. But
Well, let's think it through. So if the joystick X is -4, and I'm going to pull up the call joist routine again here just to...
yeah.
Yeah, because we called the two variables joist X and joist Y. And so if we hit left, that means the X value is -4. Okay, so if joist X is -4, in other words, if we're moving left, and the left character value is 96, then allow the movement.
Yeah.
Oh, I know what the problem is, I think.
Oh, okay.
We need to stagger these. So what's happening is that, think about it. So if joist X is move left and the character value is 96, then we say, I think I figured. I'm not sure. It might be take me a few minutes to fix it. But then we set allow movement to 0, right? But then we immediately go to the next line and say, if joist X is 4, this is not the case, and so we immediately set it back to allow movement.
Oh, yeah. So if it gets to a 0 at all, it needs to go back to the top of flow, not go.
It needs to. You need to immediately do the movement after you do that.
Do if allow move 0, just like at the end of each line or something.
Well, I think what we need to do is allow the movement, then do the movement, and then loop back. So right here, we need to stagger these. This is going to take me a minute to sort out here. So everything up till this point is fine. It's that we need to... Okay, let me think here.
What if you did then allow move : then 10 or 1020 or 10220? Gosh. Sorry.
Yeah, I'm just trying to figure out a way to avoid jumping around so much.
Oh, okay. Yeah, and then it would be the else allow move 1. So it would be like incorporated in each line as just okay. If allowed move 0, then.
Let me think for a minute. Let me think. Yeah, I think we probably need to so at every turn we need to say if the joystick movement is left and there's not a wall there, then allow the movement, do the movement, and then skip all the other stuff. So we need to run this, check to see if movement is allowed. If it is allowed, then call up this one line that moves you to the left, or whatever direction is left, I think in this case. And after you do that, redraw the stuff that needs drawing, call the sprite, and then skip everything else and skip the movement, skip the other movement in the other directions until you hit the next loop. Right?
Yeah, I think so.
I think so too. I'm gonna have to rearrange this like crazy, which is annoying because I thought it was working. The problem is entirely, before I delete anything, the problem is entirely right here. We set the value to allow movement, and we immediately, or set it to disallowing the movement, then we immediately send it back to 1 in the next line. We didn't see that.
Yeah.
Oops.
I guess I'm just not understanding why we couldn't just add in the and go to line 10,220.
Yeah, I think you're right.
The allow moves. Like,
I see what you mean.
Then allow move and 10,220 else allow move equals 1. But like if allow move equals 0 and because
So you're saying if we hit this line here,
10,220 else allow move.
Wait, why 10,220?
Because that was what you had for if allow move equals 0, then 10,220.
Oh, that's disallowing the move.
Yeah, so that's what I'm saying. If at the end of each line there, at the then allow move equals 0, why couldn't you add an and? Because that's saying.
Oh, I see.
Running into the wall, then don't allow movement and go to line 10,220.
I got you. So I was thinking.
Else go 1.
I guess I was thinking. Yeah. So you're saying here.
Yeah, and 10,220. I don't know if that's the way you would write it, but yeah, I don't know if there's like a go-to or if you just, exactly, go-to, and then else, if you are allowed to move, or if you're not allowed to not move, then you are allowed to move. Well,
let's think it through. So if we're moving left, then disallow the movement and then skip all the movement stuff. Otherwise, allow movement 1.
Does that make sense? That's what I was, just wondering why that wouldn't work.
I think it might. Yeah, it's a good call. I didn't think about that, but let's test it. I think you're right.
Oh, cool. Yeah, I'm trying to comprehend it.
That's okay. There's so much of programming I'm discovering is just trial and error, you know. I mean, if it ain't broke, don't fix it, you know.
Mm-hmm. Yeah, that's a hard one.
So you think that'll work?
Oh, that one didn't have the go-to.
Oh yeah.
I mean, we don't need that last line anymore. The 10,150.
But I don't think the reason I don't think that'll solve the problem is, think about this. So if we're moving left, and there's a wall there that disallow the movement, and then immediately go, oh, well, maybe that'll work. Yeah, okay, let's try it. I'm convinced. Let's try it.
Okay.
I was trying to talk I thought maybe it would still move on to the next line, but it's not. That's why we added the go-to. What's that? Sorry.
This extra. Do we need to take out the 10,150?
No, that's fine. It might be extraneous, but
I didn't know if that would. Yeah. Exactly.
I think it's extraneous now.
Okay, cool.
So new. I would love it if the fix is that simple. I still think there's room for improvement. It's running a little slowly, and I think we could probably tighten it up.
Yeah, I was just trying to. It helps wrap my mind around it. If I'm like, does this work? And then you get a yes or a no. It's like, oh, okay. My ideas are kind of assimilating. I am understanding.
Well, so far we're able to move, so that's a good sign. We didn't break our movement completely, so that's good.
Yes, good sign.
Yep. So let's just see first of all if we can go through the doors.
Yeah.
As usual.
Perfect.
Now let's just try going downward, but let's try going through a wall. So one step at a time, we'll hit down. Okay. And then down. Oh my God, it's working. Look, we can't go through the wall.
Nice. No way.
Dude, you did it.
That's so cool. Can you go through any of them?
I'm going to check them all. Yeah.
Nice.
It's a little slow. We really need to speed up the code a little bit.
Yeah, figure out how to condense. Oh, that's so cool. That's so satisfying.
I see what you mean about wanting the walls to be just a little more ornate, so they don't you don't blend in with them so much.
Exactly. Yeah, I just don't want the character to get easily lost in it. But I think that the white wall, having a majority white with the white character, is really satisfying though. So yeah, I don't want to lose this feel, but just add.
Check it out. It's totally working.
It's not totally working.
No, it is. Check it out. It's working.
Oh, okay, cool.
Everything's working totally as
I was like,
expected.
wait, I meant something.
No, it's great. Look at it. It's
Perfect. Yeah, it's looking great.
somehow we've solved the problem.
I love it.
This is so satisfying.
It really is. Yeah, now we have walls. We have
Yep.
working
Like,
doors.
yep. I'm hitting the up button, holding it down. I can't go through the wall, but I can go left and I can go right.
That's so cool.
It's a little slow, like I said. It's because it's running there's a lot of lines of code to do something very simple, and it's only checking for the key every time there's a call key statement. So it's not like it's refreshing 30 times a second. It's basically, if you look at the code here, or the joystick statement, only when you're on line 10,010 is it checking for the joystick. If it's doing anything else, it's not checking for an input. So that's why it's running so slow, because it's checking for a joystick, doing all this stuff, checking for a joystick, doing all this stuff. So we really need to figure out how to tighten this up.
Can we add in the call joystick in other places, or does that mess it up?
You can, yeah, sure you can. You can add it. You can add it anywhere. I mean, except where it, we could add it in.
Could that potentially speed it up if we added it somewhere else in the line?
Well, yeah, it's an interesting tension. I don't know because I haven't experimented, but basically the answer is basically yes. But you need to make sure you don't do it between where it matters. So you couldn't insert it here, but you might be able to check for it, and then check for it again right here, right before it, because it doesn't really matter here, right? It matters here. It doesn't matter here. But the more often you're checking for it, the more likely you are to detect it. So it could be maybe, but then you're adding more lines at the same time. So
True. Yeah.
I think,
Yeah.
I think definitely let's get rid of these. Now that we know it's working, we can get rid of this stuff, or at least comment them out. Let's just see let's see if it speeds up if we comment them out. Oops. You can do either REM for a remark, or in extended basic, you can just use this exclamation mark. And I'm not sure if it literally ignores it or if it still processes them. Let's see if this helps. When I was a kid, I didn't. So extended basic, I don't know if I explained this last time, but the version of basic that comes loaded into the console is just called TI basic. And then they created TI Extended Basic, and that was a cartridge you'd plug into the system to give you access to Extended Basic. I didn't have that when I was a kid. I just had plain old TI Basic. But TI Basic didn't have sprites at all. You could just use the drawn character graphics. So all this bit we're doing with the sprites, which you don't really see the benefit of here because, I mean, maybe now that everything lines up, I sort of think we should just do it with call VCHAR instead of a sprite even. It might even go a little faster. Not sure, but regardless, I'm learning some of the quirks of Extended Basic as we go because I didn't have Extended Basic when I was a kid. But everyone did. I was just a kid, and my parents didn't buy Extended Basic. But all the cool kids and all the adults had Extended Basic. It's a little better. It's those display statements were actually slowing me down quite a bit. Look how much smoother it's working better now.
It does feel more like it did in the beginning.
It does.
Nice,
Oh man,
yeah,
it's working so well. Check it out. We just need to get some other stuff added in, but the downside is, all the other stuff takes time to draw too. So redrawing the screen is every time we change screens, it's going to have to draw new stuff on the screen. But you only have to do that once.
Sorry.
Yeah, that's okay. So you only have to draw the background once.
Yeah, exactly.
Because this is a sprite. This sprite is going to move on top of other things. It doesn't actually. You don't have to. When you move the sprite, you don't have to redraw the whole screen. Thankfully. I can't believe we got it working. Check it out.
I love it.
It's so cool.
It's super cool. Can we try to make them start inside of a room that only has one door?
Definitely.
And then go into rooms that have open doors on all four sides?
Yeah. So what we don't have right now, we don't have any way of saying if you're at these map coordinates, then enable these doors. Right. So yes, we can, but we need to add all that.
Oh snap!
Oh snap! Exactly. So it might be a project for next time. But I think definitely if you want to start out where we're at, I mean, we could, we need to come up with, in fact, I'll do a little research because I think what I need to do is probably have data statements or an array. And an array, you could have sort of multi-dimensional information. You should be able to say things like, room blah 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 has this property associated with it, and room blah 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 has this property associated with it. You can store that data in an array. That's probably faster than writing, definitely faster than writing a bunch of if-then statements, I think. So, yeah, I'll just have to think of the most efficient way to handle that. Because that's what we need. We need a way of saying if you're on this room, then these values, the door values, wherever they are, where do we put them? Right here. These door values should have certain values, right? So right now we just have only one iteration of those, but whenever we change rooms, so probably where it needs to happen is probably right here, right after this bit of code. Actually, probably right here. Whenever we call the draw the borders subroutine, we need to say, we need to check and see what room are we in, and then reassign these values based on which room we're in.
I just thought about this. Would we be able to make essentially new doors, like more doors, because we already have the 4 basic doors? Would you be able to make a door that was basically just the whole bottom wall? Like bottom door, but it's just like the whole wall? Because we just did it by however many characters we wanted to do.
Yeah. Why though?
Just be able to make the map different in some areas, like be able to have a more outside, like outdoor, big, open feeling area somewhere where there's like.
Oh yeah. We had talked about that before. Yeah, right.
I hadn't really thought of that method before because this is already built this way where we have the borders all the way.
Mm-hmm.
But if we wanted to do that, we would be able to just make a different type of door in some areas where you could have.
Yeah, we can literally just say, like right here, we can just add different door. We have right now we have bottom door equals 1, top door equals 1. I think we can just add different door types. If bottom door equals 2, then basically draw a blank all the way across the bottom of the screen. But then we ended up with this weird problem of what happens when we have a wall on the left and a blank row on the bottom. That's why we end up with we kind of went through those permutations last time.
Well, it might be for just like 1 or 2 spots on the map. There might be.
Oh yeah. I mean, you could do it.
Like that big, cool area that I can't remember what the heck it's called because I don't know.
For our seaport area of the game, it'd be cool to have like water as well, not just a border, but like an artificial water, like an ocean that you can't cross or something.
Yeah, some sort of a water.
Yeah, I want to, but again, I don't know how much room we're going to have, so we're going to have to get creative with how we squeeze these things into different lines, and we're going to chew up memory. Like I think if I say size here, that's our memory we have to work with. We've got 21K free and 11K of stack space free. So That's-
How many? Is there a way to see how much we've used?
No, I don't think so.
Oh,
But I think it's 32K max, but some of it is used by. In fact, this might add up to the 32. This is the 32K max, I think.
hmm.
So we've got a ways to go, but every character we add uses a couple bytes,
Okay.
So that's why even conserving in the more than in Pico 8, there we had to deal with tokens. Here we're not worried about tokens. We're worried about total max size of the program essentially.
Yeah.
So all these long variable names are going to have to
Maybe
get.
one or two areas on the map. It could be cool to just have like that. I just hadn't thought of that.
Yeah, it's definitely doable because we could just say if bottom door equals 0, then it's a solid block. If it's bottom door equals 1, then there's a doorway. If it's bottom door equals 2, then it's totally open. Sure, that's easy to do. Easy.
Cool.
Mm-hmm.
Yeah. Perfect. Yeah, it just gives me more wiggle room with creating the map.
Mm-hmm.
That way we can have abstract, but also I want it to feel kind of open and like at least one space and just have that differentiation, I guess.
Yeah.
Different fields that feel like you're walking through different environments a little bit.
I agree with that completely because right now it feels a little monotonous.
Yeah, it could be very repetitive if every single screen basically has to have the walls all the time. We can't. There's always going to be walls.
But then I guess my question is like if you're outside and you're walking around, the whole reason we introduced borders in the first place, even outside, is because to solve the corner problem, right?
Yeah.
Which was what happens if you have a wall on the left or a doorway on the left and it's open on the bottom.
Yeah. Yeah, but I'm thinking if we made it for just like one room, then for that one case we would make the left wall go all the way down and the bottom right wall
Open.
not cover that, or the bottom wall not cover that corner.
Right. We would have to make sure that the next room is consistent with the room above.
Correct. Yes.
We'd also have to.
Yeah, trying to do it in the most limiting way possible, so we're not. Or
'Cause-
there's ways to where we can repeat.
Yeah, we'd also have to think of the hierarchy of. We have to solve the problem of the hierarchy of drawing things too, because as it is right now, we draw the borders all the way around first, then we draw the doors, and so if there's a third option, if some of them are blank, do we draw the? Maybe we draw them in.
Oh, I see. Yeah.
We'd have to have a hierarchy of which order are things drawn in to make sure everything ends up the way we expect it to look.
For the computer's mind, it wouldn't make a difference if it drew the doors and then the walls, would it?
No, I guess that's my point. You can draw the solid border first, and then you could draw the erase the then draw the blanks, the blank walls all the way across, and then draw the doors on any remaining walls. Sure, that seems doable. Sounds plausible anyway.
Okay. Yeah, it just gives me a little bit more.
Yeah, it just says to me that this code down here is going to be slightly more complicated, and we're going to have some if-then statements that say we have to have some logic that says if you're in this, again, either through an array or some if-then statements, if you're on this this map coordinates or this room, then these variables have these values, And I just need to think of the most efficient way to do that, because I can certainly brute force it with a long list of if-then statements. That is just nowhere near the most efficient way to do it. I'm sure there's a better way to do it through arrays or through data statements.
Okay.
But I don't know how to do that exactly yet, so I will figure it out. Research for next time.
Okay, I might try to do a little bit of art design for these walls.
Well, yeah. So I guess what I would do for art design. Let me go back to the manual here, and I showed you this last time, but now that you're going to do art, you'll need to think about it more. So let's go to the call char command here. So. Here's each of those characters. We had that grid of the entire screen.
Yep.
Each of those characters is an 8x8 grid. Now we have a finite amount of space to work with. Hey, my love.
So I got you
Oh,
your
thanks.
choice.
I'll have some in just a little bit.
And then I got you something for lunch tomorrow. So whatever one
Thanks,
you
my
can
love.
choose.
You're so good to me.
I love you.
You take good care of me.
I do.
Hope it goes both ways.
It does.
So each of those characters is a little 8x8 grid here. Now again, everything we add is going to chew up memory space. So we can add not as many as you want, but there are. If we go to the appendix here, let me find it. ASCII codes. Here we go. So this is how many characters we have to work with total. We've got all the uppercase and lowercase. In fact, I think maybe they took away the lowercase. Yeah, to make room for other stuff, I think. But we can take any one of these character codes and overwrite it to be something else. But then, but you only basically have this many characters to work with.
For writing.
So we're going to need all the letters because we're going to need to write stuff on the screen.
Yeah.
Maybe the numbers we should reserve. So we could overwrite, and we're going to use the exclamation point. We're going to use the, or maybe the question mark for indicating that there's some dialogue able to happen. But some of these, like character code, what was it? Are we missing a page here or something? What's going on? It feels like something's missing here. ASCII code, because we use character 96. What is going on here? Let me go back to the call CHAR statement here. I know that you have some of the character spaces are reserved in that are available in TI Basic are not available in Extended Basic because they had to make room for other stuff to make Extended Basic work. Oh yeah, so here you go. The character subprogram allows you to define special graphics characters. You can redefine the standard set of characters, ASCII codes 32 through 95, and the undefined characters, ASCII codes, okay, so 96 through 143. So yeah, you've got that many special characters to work with. So you can take that 8x8 grid and you can generate as many of these new kinds of characters as you want, but they all have to fit in between 96 and 143 or any of the standard characters that we overwrite to be new characters. So that says to me that you can't go hog wild, So what I would aim to do is to come up with a set of building blocks here where come up with a set of 8x8 patterns that you can use again and again and again and again to redraw things by putting those characters together.
Okay, so I can only make like 40 or 50 sprites total.
Yeah, and even that's probably pushing it because we might need to save some for other stuff. I don't know.
Okay, wow, for the whole game?
Yep.
Okay.
And that means, but you can put them together. So like, you can think of them like little miniature Lego blocks.
Okay.
So here's, say one of them might be a solid square, which we already have. One of them might be stripes for columns. This column filled in, and this column filled in, and this column filled in, and so on and so forth. And then you stack those, and you can make columns out of them. But you only need that one pattern, to make a block column eight blocks high. You just make stripes and then stack them, right?
Okay.
So be conservative in terms of how many fundamental building blocks you need here, 8x8 blocks, and then be liberal in terms of how you combine them on the screen to make cool stuff.
Can you flip it upside down or no?
You can't flip them. It's to be a separate character.
Dang, okay.
Yep.
Yeah, so I'm thinking for a column at the top I would want like a little overhang piece, and at the bottom I want like a foundational piece for the column to be standing.
Yeah, and if they're opposite, they just have to be two different characters. Yep.
Yeah, that would be 3 characters total for columns.
Yeah, there's no flipping. Nope.
Yeah, so they have the top, they have their middle structure, and then they have a bottom, and then you can make them as tall as you want anywhere.
Right. Exactly.
Yeah, because I was thinking the walls were basically those basic walls that we walk through in the rooms would be two tall. There would be the bottom of a column and then the top of a column there. And then you'd have the top of the wall. And then the bottom portion of the wall, you wouldn't see a column at all. You'd just see the top. Which I think would make more sense once it's drawn. And then it's just figuring out how to do the top and bottom of the screen. But I can see the left and rights in my head better. And I think once I see it on there, it might be easier to tell how it'll look.
So I think you know, again, I'm kind of hands-on guy. I think if I were trying to design stuff from scratch, I would probably get a bunch of graph paper, cut them up into little 8x8 squares, and then
I've got an app on my phone.
Yeah, do that exactly. Yeah,
Like drawing on grid paper.
sure, exactly, and then just yeah. I mean, you know, again, anything's possible. But you only have you know, what is it, 40 or 50, 40 some odd characters to work with.
Yeah.
Well, more than that, because we can start overriding the other characters, but we got to keep the letters because we have dialogue in the game. So we can't overwrite those characters. We can overwrite some of the punctuation probably that we know we're not going to use.
Yeah.
Like character 96 was, you know, I think if you'll see what happens here when we stop the program. These borders go back to what they really are, which are these little you know, backward slashes. That's why that's happening, because what's happened is if we say print character code 96, it'll print one of those, but then within the program we're saying character code 96 is now a solid block.
Okay.
So that's what's happening there. So we can overwrite some of the other characters. We just only have so many of those to do that with too. So.
Okay, so all the characters that we have access to are already things that are programmed in, and we can overwrite some of them to make our own.
That's right. And
Are there blank spots left, or is it like you're literally always replacing stuff?
No, I think character codes 96 through 143. It says they're undefined, but when I end the program, I'm still getting this. So. There might be
in that other page you showed, it did say that 96 was like an underline or something at the very last one.
Oh, did it?
Yeah, 96 was the last one in the list, I thought.
So that could be what's happening there too. So, but anyways, there's some wiggle room.
Cool. Okay.
Now there are a few caveats. One of the caveats is that anything in the same character group. So let me. Here's the expanded character set. So 96. Oh, it's a grave symbol.
Oh.
That's what's happening.
Oh yeah.
But where are the character groups here? Let me find it. Oh, is that an addendum? Was there a mistake? Is that why there was an addendum? Expanded character set. Okay. Where is the... Let me find the character groups here. Actually, if I go to call color... Here we go. Character sets right here. So each character is in a character group. Set number 0, which is codes 30 and 31, set 1, 32 through 39, set 2, 40 through 47, so on and so forth. Now, when we call those up with a call VCHAR or call HCHAR commands, we can recolor them, but everything in this color group will get in this character set will get the same color scheme. So you can go a little crazy with the number of characters you can make, but you can't go crazy with color schemes for each character. If that makes sense. Each set the foreground and background codes aren't assignable by character, but only by character set.
Okay.
So in other words, if whatever pattern we assign to character number 40 and character number 41 and character number 42, all the characters that you make up in that group will have the same color scheme when we draw them on the screen.
Okay, that part might be a little more confusing for me.
Yeah, so you're gonna have to veer towards the monochromatic and less away from multicolors within the same character.
I was thinking 2 colors top. most of the time. Like the walls, I'm thinking maybe white and black because gray wouldn't work very well with the gray background.
Yeah, probably for the columns
Might
or.
be too dark. I don't know
Mhm.
yet.
I don't know either. I'll have to just experiment a little bit.
Yeah.
I mean, you can download this program on your computer and mess with it. You can. Yeah, a little bit of a learning curve because I know more about how to make stuff happen on the screen than you do, but it's not it's not too hard to figure out.
Okay. Yeah. I might dig into that. I might just draw on grid paper because it's kind of easier to draw.
Yeah, I think you'll have fun drawing on paper if I had to guess. So.
Yeah, and then I can draw as many ideas as I have, and then anything I can come up with, and then I can send you a bunch, and then you can decide which ones you want to go with, and figure out how to make it work within the system from there. But I do have a few ideas I'm going to draw right when we get off the phone today.
Yeah, just send me some sketches. I'd love to see what you come up with.
Cool, yeah, I'm excited, but also nervous about it since it's, again, so limited with the 8x8 pixelization.
Well, in a way, it's no real different than the level of detail you can get in the sprites in Pico 8. It's just that you're limited in terms of colors.
Exactly. Yeah, I feel that same. Yeah, I feel very similar to Pico 8.
It is. I mean, it's identical. It's 8x8, right?
Yes, exactly. Yeah, very. Yeah, exactly.
It's just that you can't combine colors. Now the exception is, so there's a couple of caveats. So again, you have to make a mental distinction between things that are sprites and things that are just characters. And I know in Pico 8 that distinction is totally lost, but here we're talking about characters. And now sprites, you can have, I think, up to 28 or 29 sprites on the screen. I forget what the max is. And you can actually layer them on top of each other. So if you wanted to accomplish a multicolored thing on the within an 8x8 grid, you could do that by layering sprites on top of each other. Now the downside is you can only have 4 sprites on any given horizontal row on the screen.
Okay.
So if you plan things out carefully, you could layer sprites and get some of the multicolor stuff you want to achieve, as long as you're really, really judicious about where you do it. So you can't have more than 4 sprites on any given horizontal row, and you can only have a certain max number of sprites. And so there are a lot of caveats to that, but it's the kind of thing you could use judiciously if you wanted to achieve something extra awesome occasionally in the game.
Okay.
Does that make sense?
I think so.
Just to kind of let me give you something visual. So you're looking at my screen, right?
Yes.
Okay, I'm running the program. So even though things look the same on the screen, they're not. These borders are not sprites right now. These borders are characters. Our player is a sprite.
Yes.
So let's say I wanted to come up with another little 8x8 graphic here that is multicolor. I could come up with 4 different sprites where there's gaps in one sprite and different gaps in a different sprite and different gaps in a third sprite, and I can layer those on top of each other and achieve different colors.
Yeah.
And I could do that, but the caveat is if I do 4 of them over here, and now all of a sudden I move my player up and I'm in the same horizontal row, the sprites are actually numbered, so there's a hierarchy. It'll prioritize them in terms of number. Sprite number 1, sprite number 2, sprite number 3, and sprite number 4 will be displayed. Whatever sprite number 5 is gonna blank out of the picture because you can only have four sprites on the same horizontal row.
Mm.
But other than that, you can have 28 sprites. So I could have. I mean, and actually, this might be a way to go as well. You could conceivably have complex graphics made out of 3 different sprites where you change the colors so you have more complex colors, but only use 3. That way when your player moves up in the same row, you still only have 4 and you're still fine.
Yeah.
So if you're really thoughtful about how you combine sprites, so at any given point, on any given row, even when you're using layered sprites like that, you only use 3 at a time on any given row. That way, when your player's in line, you have 4 and you're fine. But every all that logic, if I want to define these 3 sprites and layer them on this screen, but not on this screen, that's going to chew up logic really fast, as memory space really fast. So it's the kind of thing.
To make it a sprite if it's going to move, right? it's moving? Or
Well, no, you can make a static sprite and just tell it to sit there. I mean, that's what's happening right now while I'm not doing anything. It's just it's a sprite, but it's just sitting there, right?
yeah, but why not? But I could just make it characters instead of sprites.
Except you can't layer characters like you can layer sprites.
Oh, you can't layer characters.
No. So like for example, this little corner of the screen, this character right here, there's only one of those displayable on the screen at a time. That can be a square, or it can be a number, or it can be something you define, but they can't layer.
Oh, so I can't draw a more complex border.
Well, it would have to be
One color.
It would have to be one color scheme, a foreground and background color. Yeah.
Dang it. Oh, if I left gaps though, it would be gray.
That's
I
right.
just drew with white, but if I left gaps in it, the gaps would turn the background color.
That's right.
That's correct.
That's right. Mm-hmm.
So that's how I could do it, and then the border would be white and gray. Maybe I'll just give it like then it can only be white and gray, but our character's white, so the character's always going to be able to blend into the wall there. Unless I put like something like, I guess I could do it as a different sprite over all the doorway sections there. Could I do that? Like overlay a sprite with a color over the doorways and like have a distinction. I just want to do like a black line there on the edges so that whenever Socrates is next to a wall, it doesn't look like he is the wall.
Yeah, I mean, there's a few ways you could do that. Right now, we just have the same character being repeated, but you could conceivably come up with a palette of characters so that this character here, it would be, be a little more complex code to draw it, but this character here might have a border around these three sides, and then these characters here might have a black border on the top and bottom, or a gray border, or whatever on the top and bottom. But this character over here would have to have borders over here, just on these two sides. And so you're talking about piecing this wall together, not out of one character, but out of a number of different characters that blend together.
Kind of. I was just talking about in the doorway spots on the left and right and tops and bottom, just on the in between the doorways. So whenever you're like directly standing, where the mouse is at, right there. Like
right here.
If I just put a sprite over that to where that wall, because right now you look like you're a wall. It's like there's no line at all. So if I could just put a sprite there that was just a line on the right.
You could literally just
wrap that character.
It would be a kind of I want to say a waste of a sprite maybe, but you could definitely take a sprite here and a sprite here, a little one line sprite, boom boom, and create a little partition in some way. Sure, that's absolutely doable.
For other things too, I'm sure, and building things just to extend things over by one.
Yeah, and again, the only caveat is that you can only have 4 sprites on any given scan line on the horizontal scan line in this system.
Yeah, but within that wall, there would only be two of them.
Yep, and then you would be number 3, and you'd be fine. Exactly.
Yeah, and then you wouldn't need anything else on that same line as the wall. And that doesn't apply in a column. You can have as many sprites in a column.
That's right. It's as weird as that is. That's absolutely right.
Okay. Yeah, so that could work, because then I can do a little pattern on the wall just by leaving blank spaces so they become gray, but then do little black lines there out of sprites to distinguish the doors more.
Now my only concern is every bit of complexity we add like that is going to chew up memory. So we need to still veer towards the minimalist.
Okay, I guess how much detail do you want? Because I'm trying to do very abstract, but also like, you're talking about like having columns and stuff. So
well, I think if you're clever with how you define your characters, you can probably come up with a palette of building blocks, for lack of a better word, that you can combine into interesting buildings and structures and stuff around our map. So that's not going to chew up too much memory because you only have a certain number of characters, and then we can throw them on the screen in a lot of different ways based on which room we're in. But not infinitely. We only have 32K of memory to work with, not even that much. So, and we still have to create our dialogue, and we have to create other stuff too. So I guess the priority has to be getting the dialogue working because it's a game, and that's the purpose of the game, right? secondarily, you know, highly abstract graphics, and only if we have room then and after that do we have highly detailed graphics, you know.
Yes.
But you know, but you know what we need right now? Right now, everything just looks the same. We have nothing in these rooms, right? So we need stuff to start distinguishing these rooms and build a world, you know.
Yeah, that's what I'm trying to think of.
And we need to you know, start. Yeah, we just need to start building a world. You know, we need to figure out. Probably the next thing I need to do is figure out a way of telling it which rooms have which doors, and then we can start building out our map based on the map outline we did last time with the post-it notes.
Yeah, and then we can start. I can start kind of understanding what is going to go in rooms.
Mm-hmm.
Because yeah, I guess it's hard to really fully see it because you're always looking at doors. So I'm not going to draw any buildings basically, because where would I draw the exterior of a house? You know, if you went.
I'm thinking more abstractly than you're thinking. What I'm thinking is that on any given room there would be something that indicates where you're at. And so, like, say we come in one of these rooms and we're over here and you're in an enclosed room. There's only one door and the other sides are closed. We're in a room now, but one of these rooms, like we mentioned last time, is a wrestling school, right? Well, now your task is to come up with something. I think probably only one thing, one graphic, one. Whatever it is that says this is a wrestling room, this is a wrestling school, or we just need to label it, just call it wrestling school and write wrestling school on the screen, whatever. But you know, but I was just thinking, I'd like to think in terms of icons. Like, is there something we could draw on the screen that indicates this is a wrestling room, a gym, like barbells, you know, or whatever? I don't know, right?
I think of a wrestling mat.
A wrestling mat, exactly.
There'd be 2 squares on a wrestling mat.
Right.
They kind of bounce back and forth a little bit or something, since they could be sprites. Maybe they just like.
Yeah, sprites are clever. There's lots of cool stuff you can do with sprites. Like, for example, let me make sure I save our program here. Now they've got everything working. So save dsk2.socrates work in progress. And save dsk2.socrates. Okay, so now let me find a sprite demo here. Sprite demo. Okay, these are just some other programs other people have written. Stuff from old magazines, actually.
Can't see anything right now.
You can't?
Can't. Oh, there it goes. Like, where did everything go?
Just a delay, probably. Like here, you know, sprites can really move. These are all sprites. Now, I should say too, sprites can be magnified. So these are sprites, but they're magnified sprites.
This is like, but they're never more than.
Yeah.
4 in a row.
If you look, they're carefully constructed to not conflict with each other.
Wow.
Clever, huh?
Yeah.
So there's all kinds of stuff you can do. You can write a little bit of math code that tells the sprite exactly what to do. They can move around, sure.
Okay. Yeah, so we can have a couple little squares on like a little wrestling mat. Just kind of like shaking around over there. Like in wrestling, maybe when you walk into rooms, like a little pop-up comes up in the top or something. Yeah, maybe in the top.
I mean,
dialogue's in the bottom, but setting is in the top. Oh, that looks cool.
Here's some moving sprites.
Cool.
Let's see. I think there's let me look at this. I've been typing up these old programs and saving them. Let's see. What's another cool one here? Earth sprites. That's a cool one here. Here you go. This Earth is made of different sprites that are combined and layered, I think. Once it draws the star field, it'll start to move. A little simple animation with multiple sprites. Just give it a second. Gonna finish. There you go. Yeah, the illusion of rotation by sprites layered on top of each other and swapping out as they move across the screen. And if I list out the code, so call motion, that's what's telling the sprites to move. These data lines are the values for the sprites. So yeah, there's a lot of possibilities. You just gotta think cleverly, and still be conservative in terms of how much memory we're using. So dream big, and then we'll backpedal as needed. In other words.
Okay.
Yeah, you seem perplexed or flummoxed.
I just have a lot of different ideas going through my head. I can't. Yeah, it's just.
Well, let's start with one idea. Since we know we're going to start in Socrates' house, why don't we start there?
Yes.
Let's build something for the inside of Socrates' house. It could be a bed, it could be a table, it could be a vase, it could be just something.
Okay. Yeah, I was thinking a desk, but then I'm like, I gotta make a desk.
I don't know. Socrates never wrote anything either, as far as we know. So, in fact, he didn't like writing.
Well, that's probably also what I need to do. Is I don't know anything about any of this. This is like, all completely out of my wheelhouse. So I need to go learn about Socrates and Athens a little bit.
Yeah, you should.
Make it a little bit easier to think of stuff. But yeah, it's both somehow seeming like it needs to be more detailed and more abstract than what I was thinking. Because I was thinking very abstract at first, actually.
Me too, because I like minimalist games.
I started being like, oh, maybe I need to be thinking way more detailed than I was thinking, and I'm like way too abstract because I wasn't even thinking of making a column or anything because I was thinking everything's going to be squares and lines, and it's like super, super abstract. I wasn't thinking anything very detailed at all besides in dialogue, stop motions, and then we started talking about it being a little bit more detailed, so now I'm starting to think of like even where or how to draw a building because of the way all these walls and doors are. I'm like, why would there ever even be a building on the screen because you always have the doors?
Well, I guess I sort of think of it a little more like one of the dialogues, for example, is the Euthyphro dialogue, and it takes place outside of a courthouse. I don't think you need to draw the inside of a courthouse. We just need to have a building there that kind of looks like a courthouse, and we kind of have the conversation like the top, right side or the top quarter of the map could have a little highly abstract representation of a Greek courthouse, and then the dialogue happens outside the courthouse out front. So you don't need to draw very much, just some highly abstract Greek building,
Okay, but there's a building there's no way to ever...
Yeah, exactly. No way to go in, exactly.
Doors. Yeah, so those aren't... I think having these doors here is what's messing with my head, because I'm thinking that's a door to go somewhere.
Yeah, this is more like outside, yeah.
Inside of a building, so yeah, I'm struggling to imagine there being buildings in these open spaces, I think.
Right, I think that's where... That's where I think...
And then now I'm also like, oh man, and I also only have like 40 or 50 sprites maximum, and I have to somehow draw a building with repeating shapes that...
Yep.
It's a whole different medium I've never considered before in my life.
Yep. Welcome to making a game circa 1981.
Building for up to 30 plus scenes with only 40 shapes.
Right. That's why you got to think basic building blocks as opposed to highly detailed things. Yeah.
Yeah. So I think that's where I'm hesitating the most. I'm like, oh man, this is much more difficult than I was anticipating because, yeah, not only am I trying to design like a building that I've never even considered drawing, that I need to go study what they even look like
Yep.
and make it abstract, but I also only have 40 blocks to do everything
Right.
with, essentially, and they all have to be made up of 8x8 blocks.
Yep.
Like 2 colors, maybe 3 at the most.
And again, you really have it because the player can't tell the difference between a sprite and a character, right? So
Yeah.
you can combine them in a great many ways. You do have 28 sprites total to work with. You just have to place them on a screen so they don't overlap with each other in certain ways, namely 4 on the line. And there's nothing wrong with having static sprites. There's nothing wrong with layering sprites. You just got to be careful about how often you do it so you don't interfere with your what your player needs to do.
Yeah, the sprites help out too.
Yep. So this is not so representative of what's possible because we haven't added very much on the screen. But some of these other programs, like let me just, I don't know. I think what's this program? Here Comes Santa. Let's see what that is. This is probably done without sprites. I think this one, if memory serves. Oh, I'm in the wrong version of BASIC here. Hold on. This is for regular TI BASIC. There's slight differences between the two languages. Just the one I think it is. I mean, here's an example, Very abstract. Now this is probably, you can probably do a little better than this. This is pretty simple.
Yes, I hope so.
Yeah, but you get the idea. Like, basic shapes combine, the triangles and the, squares and triangles and angles, and you can combine that with some texturing, some patterns in the characters, and you could come up with something. I'm sure you can.
Yeah. Taking in what they have here.
And you can see an example, like right here, of some of the characters that were overwritten to create special graphics here. They were really just letters that were overwritten.
Dang. Okay.
You seem so worried.
Definitely a little bit more anxious than I was when we first started this. Yeah, limiting it gets so much harder to draw things for me. I feel like it's hard enough to draw an idea out on a piece of paper.
You can always abstract. Why don't you start by drawing, and then you can abstract from there.
Yeah, I need to look into Athens more, and I think as we start going, once we start having a bit of a style to it, it'll be easier. Because right now I'm just struggling to imagine stuff for it.
Yeah, I mean, like,
difficult.
Here, Greek architecture. Here you go.
Before we ever started, I already could see it all in my head. So that's what made it so easy for me. And same with Gertrude's World. I already was seeing all that stuff in my head. So it was very easy to draw. But right now I'm not really sure what I'm seeing or, the level of detail or what it looks like. Because everything that I had in my head when I first started,
I guess
it's not necessarily.
What's interesting is you're such a graphics person. I love cool things on the screen, but I was used to playing these kinds of highly abstract games when I was a kid. So the level of abstraction doesn't bother me so much. The more abstract you have to go is fine with me. I had originally envisioned not even having much in the way of graphics at all, just like just a label on the screen that says, wrestling school or courthouse or whatever. So anything we do is cooler than.
One thing is, maybe it is more so aligned with what I was originally thinking, and now that we're getting into it and talking about it more, I'm getting a little bit more I don't know exactly what, like disoriented, I guess, because I'm starting to think that it needs to be more detailed than abstract. And I'm starting to get worried that I didn't have enough detail.
I should say too. By the way, you know, we could redefine the characters for every room. So you could say if we're in room blah blah blah, then give the characters this. So you can each room is its own ball game because every time we change rooms, we can just reassign the characters.
Okay.
If that makes sense.
Okay, so every room has 40 characters, not the whole game.
Yes,
kind of.
yes, definitely. Yeah, absolutely.
Oh, okay. Oh, well, that makes sense.
Now, within reason, because every time we do that, we're using up memory.
Yeah, yeah.
I don't know to what extent that's a pipe dream and to what extent that's possible given the memory limitations and given what else we want to do in the game.
Both stuff will be repeatable, but there might be some specific areas. Like I was thinking, I wanted more detail in the cutscenes. I wanted more of like a cutscene dialogue kind of thing. And then I drew like 1 or 2 pictures for the scene with the dialogue, and then you go back to being a square. But yeah, I thought it would be cool if it like went into like a little image. I was imagining spending most of my time working on dialogue imagery, and that we pretty much are done with the rest of the map by just having borders and little block. All we need to do is figure out which rooms need doors where and what other sprites go in those rooms, and then like some sort of little decoration. I was thinking.
Yeah, I guess I was thinking each room would have a piece of decoration, a building or a piece of furniture or something that indicates visually what it is, you know?
Yeah. Yeah, something like that. And I was thinking, something on the borders of the walls could be cool to kind of give it a slightly different feel, but I'll have to see.
Well, what can be done with color? Like if we're inside a room, we can change the color of the wall. You know, we're still going to start adding variation very soon, right? So.
Yeah.
You know, like if you're in the wrestling school, maybe it's red on the inside, for whatever reason. Who knows, right? And
red with like a blue wrestling mat.
Yeah, something like that. Exactly.
Yeah, exactly. So colors, good distinction. Yeah, I was thinking like maybe you're outside, maybe having like a couple trees or something.
Yes, something. Yeah, that's perfect. Something that just indicates we're outside now. Yes, that's perfect.
Something that while you're walking through the rooms, there's a couple little things to see.
Definitely. And and especially things you can reuse. If it's the kind of thing you can create once and pepper throughout the whole game, even better. You know.
Exactly. Yeah. Yeah, and I think that's the part I'm good for.
Well, start there. Let's just start with the easy stuff. Don't start with the hard things. Start with the easy stuff.
And I think I'm going to do the first ideas I had for the column, and I had an idea for the pattern for the walls that I thought would make it feel more Athens-y.
So I guess let's get back to looking at our game here.
The pattern's called, but it's a certain pattern I have in my head that's repeatable. So if we put it in one spot, it would repeat it around the whole border. And it would just give it like a fancier feel, I think. Or it'll be messy and...
Yeah, either it'll look awesome or it'll look... There's a fine line between detailed and garish. So...
Exactly, yeah. It's supposed to be, just messy and hard to see. It's like, what is happening? Why'd they do that?
I mean, I have no problem with pattern walls and borders sound great, you know?
I need wine with this game.
Yeah, it's weird because you know what I recommend too. I mean, get on YouTube and type in Texas Instruments TI-99 4A graphics and just do a little deep dive and just see what other people have done. You know?
Yeah, I haven't watched anything on it yet.
I mean, not everything you're going to see is possible because there are things that are there are cartridges that give you access to bitmap mode, so you can control each bit of the screen separately without characters per se. But I want to make it so we have a cassette game that anyone with with an extended basic cartridge can use. There's other more complicated things you can do. It's just that most people aren't going to have those, and then hence they're not going to buy our game on cassette.
Yeah.
So I did put in the let's see here. In the I don't need to pull it up right now, but in the design document. I did put the links to a couple of videos to watch on there.
Okay, cool.
So check
Yeah, I
out
need to go through that.
everything I put in the design
Fruits of the
document.
Forest too.
What's that, sorry?
I said, yeah, I need to go through that, and I need to add some stuff for Fruits of the Forest too.
Yeah, exactly. So spend time doing that, and
Mhm.
I will think about how to make it so we can control each room separately and control the doors on each room separately.
Cool, yeah, because from there it's like.
I don't think it's hard. I just want to find a way to do it that doesn't consist of 500 if-then statements.
Yeah, sure.
Because I think we're only looking at 1,000 lines of code total or something we can squeeze in. I mean, it's not very much.
Yeah, I feel like we don't want every room to need to be completely and totally defined, right?
Exactly. So I just need to come up with some efficient way of doing that.
Yeah. Cool. Okay, yeah, I think that there is hesitation, but it's good. I think that there's no other way to be at this point in the project.
I'm just so pleased we got it working. Like, look at it. We can't walk through walls. We
We can't go through them walls.
last time we didn't know how we were going to do it, and now it's working totally as expected.
Look at that. I love that.
But I think you're right. The walls need to be differentiated from the character a little bit.
Yeah, I need to do something to make them not. Yeah, because I like the white. I do like the white and the white on gray and everything, but.
Well, it could be Socrates could be a different color. Socrates could be black.
That's true. And also, as we go to different rooms, it'll be different colors anyways, so it's not.
Yeah, I mean, which line is it here? It's where do we define what color Socrates is? Oh, right here. So if we change line 60 and wherever else it gets called, right here.
We tried making Socrates the blue.
Do what? Sorry. Oh, make Socrates blue?
Yeah, did we ever try that?
Nope, but I can try it right now.
Sure. I don't know if I like that.
I just need to make two little changes. That's all, right here and right here. That should do it. So let me plug that in. Yeah, we need to experiment. We don't know beforehand what's going to look good. So here's a little blue Socrates on a little gray background with a little. There you go.
He's definitely brighter. I can't tell if I like that.
It's almost too bright. There's not enough contrast.
Yeah, I was like, I can't tell if I even like that actually.
But actually, what if we did something like not light blue, but like I think 5 is like a medium blue. Let me So yeah, I mean, there's only those 16 colors to work with, but you can go crazy on those colors,
Mm-hmm. Yeah, I need that color list too. It's
in the manual. I put a link to the manual.
yeah, that's right.
The link to the manual is in the design document.
I keep forgetting.
So that should be your go-to place for.
Yeah, I'll go.
And then you can always ask, of course. So let's see what a slightly different color Socrates looks like. Again, I want it to look Greek. I don't know whatever that means, but
Yeah.
The different. That's not too bad. The different other characters could be green and orange and yellow and
Yeah.
That's not too bad. I can live with that. That's not too bad.
I did like the white more, I think, still.
I like that.
I think it's because I'm imagining Socrates is like all the statues of Socrates.
Yeah. Well, it's funny because we modern people kind of visualize the ancient Greek and Roman world in terms of white marble statues, but in reality, they painted everything. What's happened is that all the paint is gone.
Yeah.
Almost everything you think of as white and marble was painted.
Wow.
So, I mean, you can kind of I don't know, ancient painted statues. It looked more like this.
Wow. That's crazy.
Yeah, and because they know because the trace elements of the paint are still on there and they can extrapolate.
Wow.
Yeah, and so when you think of them, this is what when you think of like the top of the Parthenon or something, you're talking about something like that. You're not. That's what it really looked like.
That makes so much sense.
Yeah, absolutely.
I hadn't even thought of that yet.
Mm-hmm. So we kind of this kind of idea of everything in ancient Greece and ancient Rome being kind of white and shiny. It's very much a kind of neoclassicist kind of aesthetic that we're projecting back onto it.
Yeah. Yeah, and it just makes more sense.
Yeah, like here you go. Like here's a statue here that would have been painted. They were painted. If you see patterns and stuff, they're often really very detailed patterns and things. That's what it really looked like.
Wow.
It's interesting, huh?
It is.
Like this. There you go.
Crazy to think, yeah.
Changes the whole vibe.
It really, really does.
So yeah, I mean, maybe that says to me what we need for the borders isn't so much, white borders. Maybe we just need like a pattern textures all the way around the border or something,
Yeah.
Go the other direction, make it colorful and bright, not, and then, Socrates would really stand out,
Yeah, he would. Yeah, I want to try to make this spirally, it's like a, what is it called? I don't even know. Like
Here you go.
Decorate.
Greek tile patterns. Here you go.
There we go. Yeah. Oh, shoot. Maybe I am thinking Greek then. I'm doing it right. Yeah, that blue and white one there is kind of what I was thinking.
Which one?
A little bit more overlappy on itself, though. Yeah, that blue and... Oh, yeah, they're all blue and white, huh?
Yeah.
Like right in the middle of the top row or in the bottom right corner. Like that's kind of what I was thinking. Or the bottom left corner.
But look, it's already divided up in terms of pixels. Look.
Yeah, I'm thinking of just... Oh, there it is. That blue and white one. Middle row. The third one in the middle row. From the left. That's what I was thinking. The actual edges of that. That's what I had in my mind.
Yeah, there you go. Do that. That sounds great.
Like that?
And it looks Greek.
Like
especially if it's blue and white, it'll really look Greek.
Yeah. That's what I had in my head.
Well, why don't you just Google Greek tile patterns and,
Yeah. Perfect. Yeah, that's exactly what I was thinking in my head. I'm proud of myself. It is. It will have a Greek feel then.
Yeah, I mean, I like this one as well down here.
And blue and white, yeah, that's a great idea. Yeah, I like that one. That's better. That's another cool play on what I had in my head. So.
On the other hand, these look like they repeat. They repeat horizontally. They repeat vertically, but the corner one is a special piece.
Yeah. Yeah, I think the other one, the corner one, will even repeat in the pattern, hopefully.
Yeah, but you could if it were something like this, it would just repeat the whole all the way,
Yep, something like that could be cool. And there could even be like 2 or 3 different ones for different types of rooms in the game.
Exactly. Now you're talking.
Yeah. Sick.
Screenshot this. So. My friend Odd, who knows more about the TI than I do, says best with something that fits with any direction. Yes, the more memory we can save, the better. Yes. Even these aren't bad. Look at these Greek patterns here. I mean, don't worry about the colors, but
the color was throwing me off. I didn't even see them all.
Yeah, I mean, there's a lot of inspiration here for sure.
That's so cool. I'm happy that I was in the right ballpark.
Oh, now that you're back, Odd, don't worry about the colors. We were just experimenting with colors, but look at what we have so far. Behind the scenes, it's keeping track of the X, Y coordinates of which screen we're on, and so we can go through the doors. It'll change screens. It's keeping track of which screen we're on, and we made it so you can't go through the walls anymore. You can only go through the doors. So that's what we accomplished today. Color scheme aside, we're still just kind of messing with colors. That's why there's this garish blue character, but yeah, you can go through the doors, and you can't go through the walls, and it's keeping track of which screen you're on. Yeah. So if you want to see the code, here you go. Here's our program so far, and he's used to looking at TI programs, so he knows what he's seeing a little more than you do at a glance, Dylan.
Yeah.
So we need to tighten up the variable names, of course, because we've been pretty liberal with the variable names. We just wanted to get this part of the game working first, and then we'll tighten it up. And here it is in the code editor that we're using. Not too bad. we had a couple false starts along the way, but we solved the problems and got it working. Converting between sprite dot xy or dot row and column coordinates and the character coordinates was a challenge, so that threw us a little bit, and Dylan came to the rescue here with this inserting the extra go-to statements right here that fixed our problem we were having with being able to walk through walls. So smart way to make the program. Thanks. Yeah, it's not too much code. I mean, how many lines do we have here? There's 6, and this is like 10 or 12, and this is like 20. 30 lines of code or 40 lines of code, and we have a whole map with walls and doors.
Yeah.
Not too bad, right?
Not too bad at all.
It's actually pretty good.
Yeah, I really like it.
Yeah.
The coordinates that we had on there.
What's that? Sorry?
Our coordinates that we had, like when it was showing, like.
Oh, yeah. I could put that back in for sure, but.
Yeah, I did like that.
I mean, it was right. It was this line right here that was doing it.
Yeah.
If I paste this back in now, this will give us the map coordinates. So I'll show you. Let me.
Because it really feel like you're going from room to room. It feels like the map is infinite at that point.
Exactly. Yeah. So if I run the program now. Yeah, basically, so this is the map X and the map Y. So we're on map location 0, 0. If I go north, that's going to increment the Y value, and we're now on screen 0, 1. And the starting screen is just 0, 0. So we figured we just have positive and negative numbers. And so there's no boundaries. Right now we need to define the boundaries of the map. But you can basically go infinitely in any direction now. So -1, 1. If we go up a screen, we're at -1, 2. Pretty simple. It's a pretty simple way to make a map, actually.
It's really cool.
And so each screen, now the downside is going to be the bigger we make the map, the more assets we're going to need, and the more it's going to chew up our memory. So we have to still be a little conservative. It's easy to go, God, great, I've got an infinite map. It doesn't work that way in TI Basic. I'll tell you that. Maybe have a smart way to say what screen on for the player. Yeah, so right now we don't have anything, and we're going back and forth between just having labels for each screen or having some simple graphics, because the idea is that each screen is going to correspond to a location from one of Plato's dialogues, where Socrates is going to actually interact with an interlocutor in some very, very simple ways, very extremely abstract and simple dialogue from Plato's dialogues. And but we do need something to visually say where you're at, if not just saying outright, you're in a wrestling school, or you're in front of the courthouse, or you're in a prison cell, or you're at so it's such and such's house for the symposium, stuff like that. We haven't really decided on how we're going to do that yet, but we'll figure it out. So yeah, right now it's just the map. There's nothing in it. So there'll definitely be more visual clues to tell you where you're at. Maybe some little trees and flowers when you're outside, or maybe a little abstraction of a Greek building. On the inside it might be a wrestling mat with a couple players, a couple little sprites on the wrestling mat if it's a wrestling school. If it's a symposium, at the symposium might be a dinner table with 6 little abstract sprites around it, like it's a dinner party. Very abstract, but something different on every screen, so the screens don't all look the same. You can have the coordinates and a name for the screen. I hadn't in mind I didn't think we would show the coordinates to the player, but maybe we should. Maybe that should be in the top left of the screen. Maybe we just, or even along one of the borders, maybe we just say, map XY up here and show the player exactly where they're at.
Yeah, I kind of like it.
I like it too. I hadn't thought about that, but that could actually be really helpful.
Where they can kind of see it, and it even helps further make it make sense.
Well, they always know how to get back to home base that way.
Yeah.
At least they'll be oriented. It won't just be a giant mess. That's an idea and a half.
Exactly. Yeah, they'll know that they started at 0, 0, so they can always find their way back to 0, 0.
So like up here, either maybe inside the map, or maybe in place of one of the borders, or on top of the border, we could just say map XY, and then 2 numbers separated by commas. Boom, boom.
Yeah.
That's an idea and a half. I don't mind that kind of, because that's a lot of old games did that kind of thing. You know, the things that sound annoying and you know, old games did that because you had to do it some way, and you had to do it very cheaply. You know, it's easier just to throw the numbers on the screen than it is to draw a bunch of graphics.
Yep.
So, you know, don't be afraid just to do it the simple way in old games.
Yeah.
But we're very pleased that we got the map working. You know, when we first started, we're like, I don't know how we're going to draw a map and not walk through the walls and go through the doors. And now we've got a way to, we can turn these doors on or off for any given room very easily. You know, we have a section of code right here that draws the borders and the doors. So we just have 4 variables for the doors, top, bottom, left, and right door. It's either 0 or 1. And if you change any one of these variables, it does or doesn't draw a door. And cool but steel is a line that goes down on every corner to make it a room. I'm not sure what you mean. A line that goes down on every corner to make it a room. What do you mean by that? Can you tell me a little more about that? So, but we do need something, a way of storing all the room data. So, you know, if you're on this map coordinate, then the room should have these doors and these walls.
Yeah.
Sorry, you lost me a little bit. Like that. Like what? Sorry, you lost me. Like what? Yeah, we didn't originally plan to have walls on, you know, like borders on the outside screens, but, you know, we just thought it would. I know. I guess I'm having a hard time getting what you mean just from the text comments. But we originally thought about just having an open sides to the screen and little doorways to go in buildings, but then we found we kind of ran into problems in terms of what to do in the corners and whatnot. So we decided, let's just throw borders around the whole thing, and then we'll just use other visual clues to indicate you're outside or inside on any given screen. Kind of like in the old Atari 2600 Raiders of the Lost Ark game would be a good example of how the same basic screens can be inside or outside based on context.
Yeah.
Imagine in the corner you cut the line. Oh, imagine in the corner you cut the line to make it look like a room. You mean just have like an open corner? So like an extra door in the corners? So you can go not just left and right, but diagonally as well? Is that what you mean? I mean, that's an idea. A little confusing because if you go right and not strictly speaking diagonally. No, with a slash in the graph to tell it is down. Boy, I apologize. I'm really not understanding. I'm not visualizing what you're describing. With a slash in the graph to tell it is down. To tell what is down. I also originally thought about just having little arrows, like with little labels, like cut the corners with a slash to make it look like. Oh, to make it look 3D. Okay, yeah, I gotcha. Gotcha. Just to have little. You mean just literally have like a little diagonal thing here to make it look 3D, like a picture frame. Kind of like the rooms in Legend of Zelda use that technique, I think, right? Yeah, okay, I gotcha. Yeah, like rooms inside Legend of Zelda dungeons. Like, let's see here. Legend of Zelda NES dungeons. screen, like right here. This would be an example. Like you're here, boom, 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 diagonal, to make it look like walls.
Mm.
It's interesting actually, because because that way it actually literally looks like walls, especially on the indoor buildings, inside the rooms.
Mm. Yeah, do something like that. Yeah, we could shrink the walkable space a little bit inside of rooms and give you more of a wall, more space to draw actual
Sure,
walls.
I think that would be totally compatible with what we already have in terms of not walking through walls.
Yeah. And in that case, if you're going to be going into a building, I could do just one wall on the way to where the doorway into the building is at, and the rest could be outside.
Actually, this is an interesting idea, because on the indoor rooms, they could be thicker walls like this, and that would be yet another way of distinguishing the inside from the outside.
Yeah. And then you go outside and it's back to bigger space.
Yep, that's an idea and a half. Yeah.
Yeah, and then if you're going to go inside of a room, there can be I can do the front of a wall. Like, if you're going to go inside of a courthouse or something, I could do columns and the whole front wall. A little bit of art there.
Yeah.
Be angled on the sides.
I like it.
Yeah.
Thanks for the suggestion, Odd. And he says, to reiterate, if there's space. everything in TI Basic and Extended Basic comes with an opportunity cost, for sure.
Yeah. Good point.
But we're very pleased we got this working as well as we did. I mean, the performance is what you'd expect from Extended Basic. The character is actually a sprite, and the walls are just characters. Then we just have some logic that detects whether you're next to a wall or not, and lets you move or not move accordingly. But the nice thing is, because we've only used one sprite, you can go a little crazy using sprites for graphics, as long as we're careful about not having 4 of them on the same scan line. More than 4 on the same scan line. So there's lots of wiggle room here. It would be interesting to take a stab at giving this some dimensionality. Even the doors could have be angled a little bit so they look, Zelda style. It's an idea. Although, I'm torn, because I really genuinely like this kind of Atari 2600 look. I played so many games that have this very, very plain aesthetic, and I like it. I still go back to it.
Yeah, I think that's the teeter-totter we're on right now.
Yeah, definitely. And and part of it,
much.
I will go so far as to say, at the risk of being super esoteric here, there's something really pure and platonic about this level of abstraction. Plato would love this level of abstraction, right? Because the whole point of Plato's entire point...
What you had originally talked about, too.
Yeah, Plato's entire point was that philosophical concepts are abstractions. They're not based on things in reality. They're abstractions from things in reality. So the more abstract, the better in some sense. So... Don't feel like we need to pepper this with graphics all over the place to make the point. I like the level of abstraction. It's compatible with Socrates' point.
Yeah. Simplicity is always nice.
Exactly. So, I think, once we think about it now, once, say we're having the symposium here, suppose we literally just had an abstract representation of a table, and say there's like 6 participants in the discussion. We could have a little table here with 6 other colored dots, 1, 2, 3, 4, 5, 6 around the table, and that's all we need on one screen. We really don't need much more than that to make the point. So, and I think we will probably have to keep it that simple in order to have the level of dialogue I want to have in the game. Because the dialogue is really going to take up space, because dialogue chews up characters, in the code.
Yeah, and that's the most important part.
Exactly. So, we're dreaming.
We're thinking about just doing a few designs to change up the border, like the Greek tile things you were showing.
I like the Greek tile idea. I think that'll look cool.
Yeah, I'm glad you like that idea. Yeah, that's all I was thinking, was something like that on the border. Maybe just when you're inside, maybe just the fancy buildings, maybe there's different ones. I don't know. I'll try a few different designs and we can see how they look.
Yeah.
In the program.
I think experiment,
And yeah, maybe I'll try to make like I don't know what to put inside of Socrates' house. Like a bed would be most efficient.
Sure, a bed clearly indicates you're at home, you know.
It does. Yeah, I don't know what he did at his house, or if he even had a house.
He had a house, he had a wife, and I'm gonna put his nagging wife in the house.
Oh yeah, he did say that.
Yeah,
So his
Xanthippe.
wife could be there. Maybe right from the beginning, and you can go talk to her right at the.
Yeah, I think that's exactly how I want to start the game. He's at home and his wife is bugging him about, or maybe alternatively have a little cutscene where you're talking. The Oracle at Delphi says that Socrates is the wisest person, and Socrates doesn't understand it, and so that's why. And then cue into the game, and he wants to go around and find someone wiser than he is.
Oh, that would be cool.
That's kind of how I envision the game to start. That you need a reason for doing it, and Socrates' reason was that the Oracle at Delphi said that Socrates was the wisest person, and Socrates thought that was strange because he doesn't think he knows very much. In
that case, we start off in a dream state.
Well, I guess maybe not a dream state, but a little more like an
original dialogue, I guess.
Yeah, maybe just a little, like a cutscene, for lack of a better word, but a very abstract cutscene where. Such and such is talking to the Oracle at Delphi, and the Oracle at Delphi, again, an abstract Oracle at Delphi. Maybe the Oracle at Delphi is actually some sort of sparkly color rotating sprite. And, the Oracle says, someone says, hey, Oracle, or whatever the Oracle's title was, who's the wisest person in the world? And the Oracle says, the wisest person is Socrates, or something to that effect. And then maybe they just kind of go for a minute. The other guy goes and then fade out, fade in, cut to Socrates in his house, and Socrates says, and then maybe that person is telling Socrates, so the Oracle Delphi says you're the wisest person in the world, and Socrates says, how can that be? I don't think I know very much. I better go see if I can find someone wiser than I am.
None wiser than I.
Oh, there knows what? Yeah, something to that effect, and then we're off to the races.
Yeah, and maybe his wife's there to give you like the first clue of where to go to start the game or something.
Right.
And then after you exit the house or get started, she goes to like the nag mode.
I do think a very, very basic quest system of the little imagine a little exclamation mark or a little yellow question mark above the characters that have dialogue for you. Yeah.
That would kind of give you the first like introduction. It'd be like the tutorial basically. You appear in your room, your wife's there, maybe like red or pink or whatever.
Now, of course, I worry that the tutorial is going to eat up half of our space, so I got to be careful. But
oh yeah, well, I'm not thinking like a true tutorial. I'm just thinking like you start off there and she's in the room with you with the explanation over her head, and maybe she's the only thing in the house, or maybe there is just like a vase or a table or something simple. And you go over and you talk to her to get started, and that kind of introduces you to this, look around for squares with exclamation points over them.
Just like World of Warcraft. You spawn into a game, and right there next to you is a player with an exclamation mark over their head, and it's like you can't help but see it,
Yeah, you can't miss it. It's like, oh, okay, well, that's what we should do first, is go check out this explanation point.
Yeah.
Dialogue's happening. This is a character I'm talking to.
Mm-hmm.
And then maybe she's like, you should go outside and go see what yada yada's up to.
I can probably come up with a little bit of code that basically based on a variable. If the character has dialogue available, then spawn an exclamation mark right above it. So you can do that for every character without having to program by hand where all the exclamation marks go.
Cool. I can make one exclamation point. Oh wait, no, there's already one made. That's right. And you can just make it whatever color?
Yeah, you can just change the color of it, exactly.
That's pretty cool.
Yep, just drop a character in there, and it could be a question mark, it could be an exclamation mark. Maybe a question mark might make more sense. I don't know. We'll see.
Maybe a mix of the two, that if they differentiate different things. Maybe some people just have questions or things for you to question that like can mess up your reputation, but like storyline events have the explanation point. or something.
What's great is they don't really have to do very much, you know, they can literally just be standing there with their exclamation mark, and then when you approach them, you can go in dialogue mode, and it pulls in the dialogue, and you have a little brief interaction, you know, a little slightly branching dialogue, 3 lines, 4 lines, very like the most abstract version of Plato's dialogue you can imagine. Get right to the heart of it, you know, and then boom, you're out of there in search of another conversation, you know. And maybe we'll sequence them a little bit. Maybe some of them sequence. The ones at the very end of Socrates' life need to be at the end, of course. I was thinking Greek music at the start. My sister actually gave me a link to a recording of the oldest known written Greek music that has been reconstructed based on everything they know about Greek music. And I said, well, that'd be cool. I could make a little version of that. What we can't do very easily, we can't really have music during the game because the music has to run while the code for the music would have to run while the game code is running, and TI Basic just doesn't do that. Like in Pico 8, they were separate. You could just run the music track and then do whatever you want in the game, and it just treats them separately. TI Basic is not like that. So if we have music, it's probably just at the starting screen or in the cutscenes maybe.
Okay.
But also I want to have a little sound effect, like a little walking sound, like a little shuffling while you're walking around. Every time you move, you should have a little shuffling sound or something.
Okay.
You know, but the music's...
Yeah, I was gonna say, there sound effects, yeah, because it would be cool if you could, like, when you interact with somebody, there's like a little bloop or something.
Yeah, you can definitely do that. Absolutely, there you can brief musical things that happen in specific times. Absolutely,
Yeah.
You can do that. Music that plays constantly in the background, non-starter.
Okay. Cool.
Yep.
Cool. That's good to know.
Yep. But you actually have you can do 3 instruments at a time. And one noise, there's different noises, I think 6 or 7 different noise types that you have. So at any given moment, you can be playing 3 instruments or 3 notes and a noise.
Okay.
And actually, you can probably find it here in the basic manual. I think there's probably a section on sound here.
Nice. That sounds simple enough. We can probably do this one just together on stream.
Yeah, definitely.
Sound effects. Since it's just a few sound effects, they're going to be specific, and it's all programmed from within there. And
call sound. Here we go.
Like it was too many.
Call sound. The sound program tells the computer to produce tones or noise. The values given control 3 aspects of the sound: duration, frequency, and volume. So duration can go from 1 to 4,250 in thousandths of a second. Frequency from 110 to 44,733 hertz. Noise value from -1 to -8. And there you can see the different noise types: periodic noise type 1, periodic noise type 2, so on and so forth. Periodic noise that varies with frequency, interesting. And then a white noise as well. So, you know, one of those could be used for shuffling every time you move, and one could be used for, there's all kinds of possibilities for sound, absolutely.
Perfect.
It's just that none of it can't be a continuous track that plays. It just has to be, a little tune that plays here, or a little interlude that plays here, but it just has to be queued up and played at a very specific time and then goes away, you know.
Okay, cool. Yeah, very cool.
Yeah. It's actually really, really simple, especially sounds that repeat and stuff. You know, it doesn't take too much code but it eats up code. It's not like, it's programmed music. It's not like a music track like we saw in Pico 8. You have to program it in terms of lines of BASIC that tell it what to play when. But yeah, it's one of the cool features of the TI. It had a pretty robust sound routines for the time.
Cool. That's gonna be fun.
Yeah, like I'm trying to think if I have any sound demos. I don't know if I have any sound demos saved in my. Yeah, I don't think I have any handy anyway. Yeah, but there's a lot of cool stuff you can do. So again, but everything we do eats up memory. That's the downside.
Yep. It'll help us stay very abstract.
Definitely. Well, I think I'm gonna call it a night. We've been streaming for 4 hours, and we made a lot of progress. We made it so where we can't walk through our walls, and that is big progress right there.
Huge.
Yep, and as much as I like this kind of minimalist look, I'm really curious what it's going to look like with Greek tiles as the borders, especially in the rooms, you know.
Same. Yeah, I'm very interested to see how it appears in here, see if I like it or not. But I'm gonna try out, like 3 or 4 different styles.
Mhm.
We can see if we like any of them. If we like all of them, then we have.
Yeah, and then once you've drawn them out, either you can do it in the manual, but I have more experience doing it than you, so it's probably easier for me to do it. I mean, it's not hard.
Yeah.
You basically take your character grid, use this little handy dandy chart here, and go from row 1 left block, row 1 right block, row 2 left block, row 2 right block. Find the corresponding chart for what you filled in, and then build a hexadecimal string that's 16 characters long, and that's what defines your character.
Yeah, I think after we do 1 or 2 together, I'll be able to do them by myself and just give you the code.
Yeah, I mean, you can kind of see, here's an example right here. Here's the code for the character right here. The top left block, the first 4 top left blocks right here, you can see the first digit here is 1, and that corresponds to 1 little character block here on the right. And that's what you have here in the top left. You have 1 little block filled in those first 4 blocks. On the right, you have the block on the left filled in out of those 4 blocks, and that is character number 8 right here. And if you look at 8 right here, there's the character on the left. And that's how the string is built. It's not very complicated.
Yeah, pretty simple.
Yeah, it is mind-bogglingly simple once you get the knack for it.
Perfect.
So yeah, let's call it a night, and I think we did good work. We made it so we can not walk through the wall. So it's just, if you remember last time, I said I don't know how to do that, but we'll figure it out. And here we go. We've done it now.
And we sure did. Figured out.
Yep.
Now I'm going to figure out these tile patterns, get the walls a little bit, styled up, and figure out something to put. I don't know if do we want to put something in the room with him or just his wife?
Probably something that indicates he's at home, a bed or a table or a vase or something,
A table of flowers, like a vase of flowers.
Yeah, something that just looks homey.
Yeah, table. Table always feels homey.
I'm so glad we solved this. It's amazing how much a floor. Yeah, I'm not sure how to make a floor actually. Oh, maybe just like a pattern for the floor. Maybe
I could do a floor, like tile floor or something.
Maybe, yeah. It'd have to be kind of not so garish that it's like, oh my god, one giant pattern, but a subtle pattern maybe.
Do like diamonds instead of square.
On the other hand, I still veer towards the minimalist. That was my original idea. So the more we talk about adding, the more we're veering away from my original vision. So
yeah, something simple that kind of makes sense. I feel like I need to research Socrates a little bit more.
I think you should. Yeah,
kind of understand what he might have had. I want to put something that would be important to Socrates in the room.
Well, it's so interesting because people kind of envision him as this weird guy bumbling around Athens, kind of hippie and Santa Cruz style. But in reality, he fought wars and he had a pension, and there's some evidence that his dad had plenty of money, and there's some evidence that he knew people that were wealthy, and so he sure seemed to associate with people that clearly had a lot of money. And so it's not clear at all what kind of lifestyle he really had, I think.
Oh, okay. Cool. Yeah, I have very minimal remembrance of any of the stuff from high school.
And also, a lot of Plato's dialogues take place when he's younger. You think of him as an old man, and some of the dialogues do take place when he's old, but some of Plato's dialogues take place when he's a younger guy. Like when he meets Parmenides and Zeno as a young guy. Those were old philosophers at the time, and Socrates was a younger guy meeting what were then well-known philosophers at the time. But he was probably in his 20s, when he met those guys. So, our mental images of Socrates are questionably accurate sometimes,
Yeah, I only think of him as an old guy.
What is known is that he was generally considered to be ugly and had a bit of a pug nose. That's generally well known. Yep.
Yep.
And what did he say? So in one of Plato's dialogues, I think one of some younger guy asked Socrates if he should get married, and Socrates says, absolutely, you should get married. If you have a good wife, you'll live a happy life. If not, you'll become a philosopher. Oh, Play-Doh. Yeah. So I still like the idea of having Bill and Ted, one screen with Bill and Ted in a phone booth in search of Socrates. So
Yes.
Socrates.
Yeah, I forgot about that. Yeah, we should do that.
I think that's going to be a funny, weird idea too. Some weird little Easter egg. And Susan says you have to watch Bill and Ted's Excellent Adventure. It's just criminal that you haven't watched Bill and Ted's Excellent Adventure. So.
Okay. Yeah, I know. I haven't watched like any movies. The amount of people who have said stuff like that to me about so many movies. Yeah, childhood away from technology, man. In a world that was embracing it.
Well, it's funny because I was playing with stuff like this when I was 3, in 1981. So.
Right. Yeah, I was born in '95, and my parents were like, "Yeah, you're not going to really need technology as you age. It's just like a fad." And I grew up, and I was like, I feel like I'm just detached from everything that everybody else is attached to right now.
So right now we only have joystick control here, but we need to add keyboard control too. So those call joy statements I did for expediency, but we actually need to program keyboard control as well in order to really make this usable. Which means we're going to have to change it a little bit because the joystick spits out the -4 and whatnot. We're going to have to basically detect the key press and then take those values and do something with those values as well. It's different. The keyboard works different than the joysticks do, so we'll have to modify our code we already have in order to add keyboard control. It just so happens that the emulator lets me use the arrow keys in place of the joystick, but we're not there yet.
Not there yet. Nope, we're gonna put a paint or something in this.
Yeah, at some point I'll start making a task list on our project management board as well, and we can check things off the list like we did for the last game.
Oh yeah, our Trello.
Yep. In fact, I'm going to take a screenshot here. I'm going to use this screenshot as my new screenshot for the game, or for the stream. Boom, there we go.
Nice. Yeah, I'm pretty happy with where this is going, and I feel like we got a lot talked about too. I feel a lot better about the art now.
Yeah, I don't really know what it's going to look like. We're going to have to experiment a little bit and see what we like and see what we don't.
Yeah. Yeah.
The good news is, we don't have to put anything in we don't like. The more abstract we make it is fine with me. So if something really isn't working, we just go, we're not going to do that.
And just take it out when we don't like stuff.
Exactly.
Anything we do like is part of the game.
Absolutely.
Cool. Okay, yeah, I like where we started.
Me too. Look.
Next time's going to be fun. We're going to get into the actual game now.
I think so. I think we're to the point where I can start thinking about, we need to figure out how to enclose the rooms we want to enclose and figure out which doors are where and which screens. And then we can start populating it with, if you're on this screen, then draw these other characters and draw these borders and these colors and, start defining the logic that makes up the map details, and then we can tell it what to do.
That'll be so cool.
I'm not sure how far we can get before we run out of room. Well, it's to be determined. So.
Yeah, especially if it doesn't tell us how much space we've already taken up.
Well, no, it does say how much we have left.
Oh, it does say how much we have left?
This is how much we have left, but it doesn't say how much we've used.
This is how much is... Oh, okay. I thought this was how much there is total.
No, this is how much how much is free.
Okay, and we started off with how much?
Well, technically it's 32. I think these two total 32K, so we haven't used very much. But
oh yeah, it's still like right there, 32. Over 32.
Somewhere in there. But I think it goes quickly if memory serves.
Okay. Yeah, we can just keep tabs on this.
Exactly. We, next time we'll be able to. In fact, I'll take a screenshot. We'll be able to compare how much code we've added and how much.
Good idea.
We can estimate that way.
Yeah, see how much we use next time.
And then, of course, once we're confident that a section of code is working, we can really go, oh, a third used. Is that really true, Odd? Have we used a third already? No,
really?
That can't be right? Tell me that's false.
The third?
Yes, he says yes. In extended basic, really? We've used a third of the available space already.
Oh gosh, okay, yeah, we gotta shorten the crap out of everything then.
Yeah, you can see the problem in working in BASIC.
Yeah.
I mean, worst case we shift gears and do it in another environment. I would just really, really like to do what I can in TI BASIC, you know.
Yeah, it's true.
All right, so that says to me we really need, you know, we'll have to tighten up a lot of this stuff. A lot of these variable names, are becoming one character variable names or two character variable names. We're gonna
make them as short as
we'll
possible.
combine lines wherever possible. Yep. So we'll do all the techniques, but you know, we just wanted to get it working at first, and then start tightening.
Yeah.
The comments can go away once we're done with the comments.
Dang, yeah, already at a third. Yeah, because we have to write all the dialogue in
How
there.
can we be at a third already with only like 30 lines of code? Really? That can't be right. Spaces
I
are
feel like it's gonna be
even in extended BASIC.
have to write for the just the dialogues themselves. Because there's like 30 different rooms or something, like 30 different points of dialogue.
But what about with the 32K memory expansion? I'm assuming that we have access to the 32K memory expansion. Because then, you know, anyone who's going to run a real TI has a real. Then it's better, yeah. I'm assuming that anyone who's running a TI has a 32K memory expansion at this point. If not, then they can buy one. Right? They're out there. That's what I was assuming. Not console basic, but 32K memory expansion TI extended basic. What in that situation? Then what is it? More like a sixth of the way. Classic 99 has much space. In worst case, we just make a Classic 99 game. I would just really like to be able to sell this on cassette, old school style, just for nostalgia purposes. So I think one of the options here, I don't remember how to find it, but I think one of the options here in the emulator. Oh, I'm in the emulator. Here we go. I think one of the options here is, do you have the 32K memory expansion on, or not? Or maybe it's even more. I don't really know. I'll have to do a little research, but I want to be able to do it. My original idea was TI extended basic plus the 32K memory expansion, and that's it. So you can still sell it on cassette, and most people are likely to have those two things: extended basic and a memory expansion. And people who have those things. What's that?
I was just gonna say, if we're already that full, we could just focus on getting the dialogue in there and see how much space is left before I get too creative with the art at all.
Well, we could do that. Why don't we do that? Let's see if we can at least start getting a basic dialogue system implemented.
Yeah, getting the map to go in the correct chronological order, to where you were in a house and you go outside and then you go to the left and then you see the first person to talk to or whatever.
Yeah.
And start doing the dialogue, because I feel like the dialogue in and of itself, I mean, that's just characters you got to write out. It's going to take up space.
It is going to chew up space. That's why I'm thinking, you know, if they're with dialogue, I'm not talking about pages of dialogue. I'm talking about 1 or 2 or 3 or 4 lines per little dialogue. You know.
Yeah. But there's like 30 of those.
Exactly.
So like,
and come up with a little miniature dialogue engine that lets you, you know, move between different lines of dialogue in a way, and then just keep it to 3 or 4 lines or 5 lines per discussion, and then that's it. You know.
Yeah. And then come back on the back side of things and add in art, whatever art we have space for.
Exactly.
Then we can throw, because it all has to be programmed in.
Yep.
So if the dialogue takes up, I don't want to sit here and waste a bunch of space with art, and then we can't even get the whole premise of the dialogue in.
I mean, as cool as it would be just to have an open world exploration of ancient Greece, I really did have in mind that this would be about Socrates. You know.
Yeah. Yeah, so we can focus on the dialogue and just getting the map oriented right, so that you're kind of following the map along.
So what I need to do for next time is basically think of the most efficient way to contain the data for each room. You know, which means where the doors are, what color it's going to be, and what characters are going to be in there, and you know, so on and so forth. All that has to be contained in some way. You know, and I gotta. There's a brute force way to do it with a bunch of really long if-then statements, but I think there's got to be a better way of storing that information in data statements and then reading those data. Because there's a way of storing data here. Let me. I know I keep saying we're going to end the stream, but I do need to go have some dinner. But there are data statements that let you store complex information as strings of data, essentially, that you then recall a piece at a time. So I think this is probably the way to store the information about the rooms. I just don't know how to do it because I don't have a lot of experience with data statements. So I need to read this, look at some examples, try a few things. Because it really could be like, you know, the data could be, you know, one data statement could be the four values for the doors, up, down, left, right, doors on or off. It could be up, down, left, right, and then the sequences after that are which, you know, how many non-playing characters, or is the dialogue available, or what colors the room should be, and you can just build all that into one data statement for every room. So yeah, so that's what I got to think. What's the most efficient way to pack the amount of information we need for each room into the smallest amount of room? And I think it's probably with these data statements, because you can just go up, down, left, or right, 0, 1, 0, 1, whatever, and then you can have, you know, 3 non-playing characters, blah blah blah, coordinates for the non-playing characters, blah blah blah, colors for the borders, blah blah blah, all packed into one data statement. Then all you need is a little engine that reads the data statement and builds the room accordingly.
Perfect.
So I think there's a way to pack in a lot of information about each room. Now that's not graphics though, that's just room information, right? So that's generic stuff for every room. But then when we get into, now we need a temple in this room and a vase in this room, now we're going to start chewing up our space. But I think the basic room information, you know, is there a conversation available here? Yes or no? Is there a non-playing character here? Yes or no? How many non-playing characters? What are their coordinates? What color do you want the walls to be? What color do you want the floor to be? Blah blah blah. I think that's actually gonna go really, really efficiently.
Perfect. And that's what I was thinking most of it would be anyways. And then yeah, if there's room after all the dialogues are filled in and all the rooms are made and stuff, then we can go in and add extra little details.
Exactly.
Extra pieces of art in there, maybe some trees outside and tables or vases or whatever. Some columns somewhere.
So generally you have, to read a data statement, you generally have a loop. So you say, you know, you define a variable for a equals 1 to 5, and it loops through that, and then it basically loops through the entire data statement. The first loop, it gets the first piece of data. The second loop, it gets the next piece of data. The third loop, it gets the third piece of data, and so on and so forth. So you basically just create a little engine that reads the data statements and does what you want to do with every chunk of data, and then builds the room accordingly. And so just do that every time you enter a room, and read a long data statement, get all the data you need, build the room, and you're done.
Sick.
And just have the same engine for every room.
Yeah. With different variables. Yeah.
Yeah, or just same variables with different values.
With different inputs for the variables.
Exactly.
Right.
Right.
Very well,
But yeah, so I think there's a way to do it. You know, I think we'll be surprised how much, as long as we're creative with what we build the room out of. You know, you'll find that we can use the same engine again and again and again and again, and you know,
that's the method we want to take. Yeah, because that's going to give us the most simple but like also sturdy feeling map, and then it's as abstract as it gets with only giving you everything you need to have and nothing more.
And it literally could be that if we have 25 rooms or 30 rooms, that could just mean 25 data statements and 10 lines worth of engine, or 20 lines worth of engine, and we use, you know, a total of 50 statements to build the rooms in every single room of the map.
Yeah.
I think that's realistic, I think.
Cool. Yeah, and then we don't need very many rooms that aren't dialogue associated.
Yep.
But I think it would be good to have maybe a couple, so there's like not every single.
Oh yeah. You should explore a little bit. Yeah. Through. Exactly.
Cool. Yeah, I think that's a good idea, and I think that I might still just work on the art for those, like the tile design, just for fun.
Yeah, you should.
I had it in my head already. And then I think I might just pause on the art for this game and focus my energy on the fruits of the forest, figuring out what software I want to use for that and starting to get more of a design going, but keep focusing on Socrates.
Sounds like a plan. I'm ready to work on that game as well. So, you know, whenever you want to dive into that, we can do that as well. So.
Perfect. Well, I think that after I've picked which one I want to do the art in, after I pick a site to do the art in, and I pay for it and get a character, just a basic character made, I'll be more ready to jump into something on that one.
Definitely.
We're not in a super big rush since we have this other one going, and I'm enjoying our pace where we're at in this right now. I feel like we're off to the races.
I think we're actually making a huge amount of progress pretty early. You know, we've done 3 sessions and we have a working map, you know.
Right? Yeah. This already feels so secure, so sturdy and ready to go. This is so close to what I was imagining in my head already. Yeah, it just needs the stuff in the different rooms.
Yeah, and I think what I'll try to do is, you know, before next time, or maybe when we start next time, we'll just sit down and brainstorm what are all the pieces of information we need to know about a room.
Yeah.
To build a room. Other than the things in the room, the room properties, you know.
Yeah. It's doors, it's color, who's in there.
Exactly. Then I can start making data statements, and I can start coming up with some engine that reads the data statements and then builds the room every time you change rooms. It'll just call up the right data statement, and then it'll read the right data statement.
Cool.
I hope anyway.
That sounds like a great place to start. Yeah, because then we could program room 1 to be one thing, and then if we had room 1 be one thing and room 2 be another thing, that would already blow my mind.
Yeah, I think it's realistic that we'll get there the next time or the time after that. So
that's what I'm feeling too. Yeah, that's why I want to stay focused more on this game right now, but I will do stuff for the other one in the background. I have been thinking about it. It's all in my head. I just haven't been writing or drawing it. I've been too much music, and there's birthdays this month, so I've been more preoccupied.
I get it. I do.
Perfect. Cool. Okay, yeah.
All right.
A lot of fun today.
Well, good work.
Yes,
right to us both. Thanks for tuning in, Odd. I appreciate you tuning in. And anyone else who's watching, thanks for tuning in. And we'll be back sometime within the next week. If not Sunday, then next Thursday, I think, in all likelihood, unless something comes up on either of our ends next week. So look for us for session number 4, and we'll try to making these rooms look like something interesting.
Yes. Let's go.
Let's go. Exactly.
All right.
Have a good night, everyone. Have a good night, Dylan. Good night, Odd.
Yep.
Catch you next time.
Bye.
Saturday? Yes. If I can. I'm not sure yet. I'll make it if I can. But have a good night in the meantime, and I'm going to go have some dinner, and I will catch you on the other side, so to speak. Have a good night.